everyone. Happy Friday. It is Friday, right? Don't ruin the dream. It's Friday. It's Friday because I can sleep in tomorrow. Yes. Okay. Whew. All right. It's been a week. It's been certainly a week for a lot of people, I think. But I am extra grateful for the weekend. I don't know about all of you. I need to sleep. I need some video game time. Still haven't played any video games, so I need to be in pajamas with video games and not thinking about anything else for a little bit. So, TGIF, exactly. Let's see. Hello, Nidia Only, and hello, Edwin STZ, and hello, Crow. Hi, everyone. Welcome. This is our last day of Machine Learning Miss. I'm gonna miss it. This has been lots of fun. Hi, Ian Alex Hart. Welcome. Thank you for your bits. Loafbone, how are the dogs? Because there's actually going to be a great pausing point once we just get through like the intro stuff. That would be a great time to give the dogs some treats. Okay, we'll let Hub snap a little bit, and then we can wake him up the best way, which is with lots of treats. And Toasty, when you ask what games I play, everything that's not a racing game or a sports game. Unless it's like racing and sports, because then you have Rocket League, which is really, really fun. So, but I honestly, I play a lot of different games. Video games are my stress relief. But in any case, those of you, especially those of you who've been here for most of the days, if not all of them, look at all of these topics we've done. You should feel extremely proud of yourself for going through however many you did. Learned a lot about all different kinds of machine learning, and today we're going to be talking about computer vision. And so actually, I have a really, really cool special thing today, which is that one of my colleagues is going to join us for the last part of this stream, and his specialty is in computer vision. And so he's going to be joining us to answer all kinds of questions about computer vision, and yeah, it's going to be cool. I don't do a lot of computer vision, so I wanted to get an expert, though he'll probably deny that he is, but he is. And Toasty, what do you say? Reinforcement learning? Yes, reinforcement learning. Not today, but we will do more reinforcement learning. And hi! Okay, so in chat, Faultline64 is going to be our guest for the evening. This is my friend Tyler. Tyler will be joining us for the last part of stream. So I get to, show you some cool concepts. We're going to learn what a convolutional neural net is. And then Tyler will hop on and we'll get to chat and answer all your questions, and it's going to be great. Oh, and you meant Rocket League. Oh. See, I'm so much in like the 12 days of machine learning miss mode that I see RL and I'm like, yeah, reinforcement learning. I just thought you were geeking for reinforcement learning. So, as one does, as I've done for like many hours now. Like I think our longest streams were the RL streams just because RL's amazing. But Rocket League is cool too. Do not fear. Rocket League is also very cool. Okay. So, as always, I like to start our streams with a question session a little bit, just in case anyone has leftover questions from previous topics, or hopefully no questions yet about computer vision because you haven't learned anything. But if there are any questions about previous topics, I know the VOD from yesterday is not up on YouTube yet. I need to kind of stick the two videos together because Twitch died in the middle of stream. Thank you, Twitch. And so I've got to kind of smush the videos together, make it look decent, figure that out. So once I've got that for all of you, that will be up on YouTube. But let's see, what did we do yesterday? So the code and the notes they're already up on GitHub. But in any case, alrighty, let's see here. Looks like our music is barely here. I'm gonna turn up our music a little bit. There we go. Okay, so any questions while I'm getting our whiteboard set up? Any lingering need to discuss something? Absolute confusion about anything? Let's see. Alrighty. Well, if everyone is just like, experts in machine learning, that's great. You all can do this next one then. Just kidding. In particular, since we're going to be talking about a specific kind of neural net today, if there is any leftover confusion about the neural nets that we've done, the neural nets we did for reinforcement learning, and some of the neural net kind of graph theory that we learned on whatever day that was. Today's Friday, Thursday, Wednesday. I can count. Now would be a good time to ask, just because I'll do like maybe I'll have a little bit of review, but just in case, if there is anything that anyone is still confused about with neural nets, or if you all feel like neural net experts, that's also fine too. That'd be awesome. 2 days of streams and you're neural net experts. Wouldn't that be great? I wish it worked like that. All right, so let's see here. I'm just gonna get a few other things set up. And virtual assistant, you have a question. Yay, hi, and welcome. You say, what about chatbots that use NLP? Ooh, what about them? Are you just interested in like how that works, or do you have a specific question about chatbots? It's really cool actually, because if you think about it, there's a lot of different natural language processing tasks that have to go into a chatbot being successful, right? So you need kind of that language, that natural language understanding that we talked about, so machine comprehension. The chatbot needs to be able to kind of read, if you will, what it is that you've said, extract meaning, also be able to understand some of those contextual and paralinguistic kind of signals that we talked about last time. So things like, it needs to understand punctuation, needs to understand different forms of questions, things like that. And then it needs to find the answer. So that's some of that like semantic search that we talked about. And then it has to have language generation as well, because it needs to be able to respond. So this, of course, if your chatbot is more like an Alexa or something, then there's a whole other layer on top of that, which is the speech to text, text to speech conversion as well. So that's like, for instance, my Alexa, I can ask the Alexa to add things to my shopping list, and I can give her, like, I can say, well, my Alexa's coded to computer, so I can say, computer, add cheese, bread, steak, whatever, to my shopping list. And not only will the computer understand what I'm asking, she'll understand that it's also a list and add those items separately. So there's a lot of really, really cool language parsing that happens with all different kinds of chatbots, or those like personal virtual assistants. Virtual assistant. I get it. And Toasty18, you say, can NLP used for programming languages, AI that writes itself? So yeah, I think there were some folks in chat yesterday telling me about some like additions to .NET that are like that. I think, at least for the purposes of building the kinds of models that I've used, it would be kind of slow to do that, because usually when you're working on like a model that's going to do some predictions, or like the sentiment analysis that we did, you want it to be fast, you want it to be snappy. And if I'm trying to kind of get the computer to translate to one language and then translate back, it's adding a lot of additional tasks. But I can see the use in like perhaps keeping up a like a code base, having like automated like cleaning or something like that. But so yeah, virtual assistant, exactly. It's possible, but I haven't seen as much of it, at least in the kinds of problems that I work with. And Amaru92, thank you for following. And yeah, don't worry, Mr. Ed makes your job as safe. I think that there are definitely things that can be automated that would make all of our lives a lot easier, a lot better. But the fear, I think, for machine learning to fully replace humans is a little premature. Like, we might get there someday, and then we'll have that conversation, but we're not there yet. We're not. There are like menial or laborious or like manual tasks that computers can definitely step up, and machine learning can do that, for example. But for now you're good. Alrighty, so let's see here. I'm gonna get over to our whiteboard. Do I have everything I need? I do. Okay, whiteboard. And Axel, you ask, how did I get a Wikipedia page? I don't know. So I was involved with a lot of advocacy and activism within the American astrophysics community. So that might be why. But I don't know. Sometimes it does seem kind of random. I definitely have had like professors with Wikipedia pages, and then I've known like really, really prominent academics that don't. So who knows? I don't know. You'll have to ask the people that have edited the pages or whatever, make them. Okie dokie. So, computer vision. I have been asked probably more questions about computer vision and neural nets in general than I think any other part of machine learning. And C3X111, thank you for following. And just programming things, hi. You say, would it be feasible to use NLP with analysis of, for example, plagiarism? Absolutely. So that would, it'd be a different kind of detection than an example we talked about last time, which was like author identification. But absolutely, I think that would make a lot of sense to use NLP for plagiarism. So you could do it a couple of different ways. You either could, you know, I guess the way I might do it is if you're putting me on this spot and I have to like right now build an NLP model or you know application to detect plagiarism, and this is off the cuff, all right? So like I could be totally wrong, which happens plenty of times, but the way I might do it is I would, like, if this is to detect plagiarism in like a student's work over the course of a semester, for example, one way you could do it is by like uploading all of that student's papers and essentially getting a model that will learn that student's like writing style and then look for, you know, statistically significant abnormalities in their writing style, and then perform either like a database search or just even a Google search or something for those phrases to see if they match up somewhere. And then it can flag things. So that might be one possible attempt, but that would also require enough samples of a student's writing. So that could be a downside. Flux Quantum, thank you for the TGIF bits. Yes, thank goodness it is Friday. But see, that's just like I'm spitballing there completely, because this is one of the things that I like to do, at least when I'm building machine learning models, is because I have worked in a lot of different fields and built models for a lot of different reasons. I'll do like, I always like to do a little bit of research just to make sure, because, you know, it's a constantly evolving field. And so there's always new methodologies, new model architectures and stuff. So, and then I kind of just like brainstorm and kind of start to think about all of those things that we've talked about through our 12 days of machine learning this, like all of those trade-offs, right? And so the more you build models, the more you kind of will get a feel for stuff that's going to be slow or things that might be obstacles. And so then considering a lot of the different pros and cons, and then, you know, you kind of go from there. But let's see here. And yeah, of course, just programming things. I'm glad I answered your question. Again, it's probably just one approach. There's probably many, many approaches to how to do this, but that was just off the top of my head one thing you could do. And let's see, Rat-a-tat. You ask if TensorFlow is going to be used today. So I had originally gotten some code for tonight that it was going to be Keras and TensorFlow. And I was going to train it before stream, and it took so long to train that it wasn't going to be ready in time. And so then I considered, like, I could just get a pre-trained model maybe and just show you, I guess. Like, we could just run the lines of code, but then I don't feel like that's very educational. And Cattleco, thank you for following. So in lieu of you know, building a full computer vision model would be outside of the scope of just a couple of hours. And those models often, for like the coolest examples, they do take quite a long time to train. Some of the simpler ones are faster, but those are often like the most commonly used. And so I was trying to come up with something really cool and unique that we could do. And in lieu of that, though, as I said earlier, I'm going to be having one of my colleagues who does computer vision exclusively. And no, Tyler, you can't say you're not an expert if you're still listening. He's an expert in CV. And he will be joining us for the last part of stream to answer questions, talk about the nitty-gritty details, tell you about cool computer vision-y stuff. And so that will be how we're going to close out the 12 days of machine learning miss. But also Tyler can talk, you know, another perspective other than mine about what it's like to, you know, build machine learning models for a living, what it's like to do either machine learning engineering, data science, all of that stuff. So it'll be a nice way to close out the 12 days is by having two machine learning people here to answer all your questions. And see, Tyler, exactly. I'm right. You're smart. And Daniel42 say, do I know deep fakes? Depends on what kind of deep fakes. So we did talk about yesterday NLP deep fakes, so things with text generation that are made by a computer but seem, and completely made up, but seem very, very real. You might be talking about deep fakes with imagery. And so a lot of times that's done with generative adversarial networks. And that wasn't something I had time to talk about in the 12 days of machine learning miss. But maybe that'll be a great topic for a future stream. Because like I said, once we're done with the 12 days, I'm going to take just a little bit of time off streaming. And then we'll go back to our regular stream schedule. And so that'll be Science Sundays, where I'll do data science / machine learning or space science, and Math Mondays. And then Viewer's Choice for Tuesdays, so y'all get to pick. And Game Dev on Thursdays. And Captain Canuck Dota. Thank you for following. Are you a Dota fan? Welcome. I like Dota. I'm very bad at Dota, but I like Dota. And so let's see here. And just programming things you ask, what about finding similar in meaning sentences? Like if someone says smiley versus grinning, except rather than one word, it would be a phrase. Yeah, so that's like semantic linking. So that is definitely something that natural language processing can do. And it's a very like common NLP task. So let's see. Mr. Ed makes you say, for humans, it's easier to find edges in moving shapes. And is it easier for computers that way too? So you mean, you're asking specifically, is it easier in moving images versus, so in video versus a single image? Is that what you're asking? I just want to make sure I'm going to answer your question. And Captain, oh, okay, you say you're big on Dota. Yes, I'm still with strats. So it's kind of like a hobby thing. So I do it when I can, because it's not my day job. But I've been enjoying it, and I love working with the data. Like Dota data is hard. It's hard in really fun ways, and so I've really, really liked tackling some of those challenges and trying to see ways that we can, you know, evaluate and analyze that data better. But it's tough. Yeah, that kind of data is any data where it's like human behavior and human performance is going to be really noisy. And so and also Dota being this like incredibly dynamic game where patches can drastically change what play styles people have, what choices they make, what heroes do well against other heroes. So it's been a challenge, but it's been so much fun to do. So I'm sure you know all of this. I was just geeking a little bit. And Algebra 97, you ask, what kind of math topics do I do on Math Mondays? Well, guess what? Math Mondays is new. So that is going to be a new stream series coming to my stream near you. And I'm going to be starting all the way back with algebra. So I want to start, like I've said before on previous streams, I want to cast the widest net. And algebra is where a lot of people start to hate math. It's where they start to get confused. It's where they start to just memorize rather than understand. So I want to start there so that hopefully I can repair any damage that bad math teaching has done and get folks to like math again. At the very least, have some fun with math and understand it better. So that'll be starting soon. And let's see, Captain say, Dota data is super hard, almost endless edge cases. Oh, right, seriously. Especially with machine learning, because it's just like, you want to have accuracy, but then like those edge cases are often so important. Not to mention like volume of data and processing the data and, you know, just it's so complicated. That's why what was it? I was reading the, what was it called? OpenAI's Dota 2, it was like deep neural nets and reinforcement learning. The system that they built to play Dota, or a simplified version of Dota. And it was like, there were billions of choices that a Dota player can make in any given second, which just like, I'm probably one of the crappiest Dota players out there. I love it, but I'm very bad at it. And no wonder it sometimes feels overwhelming. I remember when I was very beginning and starting out, I was like, oh my God, it actually would stress me out. I'm like, I have to take a break from playing this game because I'm getting stressed out by all the things I have to keep track of. And Magnusine, thank you so much for following. Okay. And let's see. Algebra 97, you say, math is one of the most useful things that ever existed. Yes, agreed. And Mr. Edmakes, you say, are you planning on any streams to share my knowledge of galactic nuclei? I have done so many streams on active galactic nuclei, but I would love to keep going. As long as there is interest in supermassive black holes, I am here to make streams about them for you. So absolutely. And Magnusine, you say, I've sold you on Math Mondays. Good. Yes. All right. Welcome to the Math Lovers Club because, oh yeah, math is wonderful. And Captain, you say you were a tester for the OpenAI 5 project. It was a wild ride. Oh, that's really cool. Man, this is where like the pandemic sucks. I'm like, I want to get beer with people like you. Like sit down and hear all about that because that sounds so cool. I've worked a little bit with the Alpha Star stuff because they've made a lot of that open to the public and you can use it, play around with it, mess with it. That's how I actually learned reinforcement learning. And I can't imagine the complexity and the difficulty of building something for Dota. Oh goodness. Yeah, that'll get me off track because I'll just sit here like brainstorming the whole time. And let's see, Detox Mango, how much speech translation do I have to know to work as a machine learning engineer? What do you mean by speech translation? Do you mean like speech to text? It depends on what area of machine learning. Like I've never done speech to text. I think sometimes, especially if you're new and you're starting out, it's more about learning like the concepts, good like software development practices, learning like kind of good families of models and approaches. And then if you want to specialize in an area, you can go really deep into that. Oh yes. Okay. Discord beers. That would be awesome. And also I want to hear about Dota Buff and I want to hear if you like working there or I don't know if for you it's like volunteering. For me it is, but I'd love to hear more about that too. Okay. So let's see here. All right. After all this, it was great. All the questions. So computer vision. Okay, let's talk computer vision. So it's really funny because I thought computer vision, especially with how much it makes the news, like folks would mostly know what all of this is already. But is there like, what do you think computer vision is all about? I want to hear, because I'm actually curious what people, especially if you haven't heard of computer vision before, if you only read like news about it, what kind of you perceive computer vision to entail. And cheers, MH and Airman. I will hydrate. It's Friday night. Fridays. And you say it's your full-time gig? Oh, that's awesome. Okay, yeah, then I definitely want to hear more about it. Processing images. Okay. So Algebra 97, when you say processing image, remember, I'll give you a little bit of a hint here, right? This is the 12 days of machine learning, miss. We are talking machine learning. What kind of machine learning would you imagine being involved with image processing? And MH Zannerman, yes, you say face recognition. So facial recognition. You started with like one of the most controversial kinds of computer vision. And let's see. Image recognition. What kind of image recognition did you do? And yes, Algebra 97 and Andre Apolari and Detox Mango. Ooh, you know, I'm not sure I've read any lip reading. Oh, that's interesting, actually. Now I want to look that up. I haven't actually seen models to do that before, so it makes sense, but it would also be so dialect dependent, and everyone has kind of, sometimes we have like unique quirks as to how we position our mouths for different sounds. So anyway, that was me starting to, again, brainstorm and daydream. But let's see. Yes, okay, so we are interested in enabling, I like the way you said that, enabling the computer to understand images. Okay. Okay, so Algebra 97, yeah, you know what you're talking about. So we've got edge detection, detecting edges, face recognition, face detection, anonymizing faces, yeah. So we've got the detection of things, we've got recognition, and so these can be applied even broader than just like edges or faces. You can talk about object detection. So that kind of maybe would be like the oh no, I don't want to scroll. I need to scroll this way. Object detection, object classification. So if you're already kind of like, wait, what's the difference here? Object detection is kind of where is the object? And object classification, you can kind of think of that more like, what is the object? Of course, if I say anything that's like abhorrently wrong, Tyler, correct me. And then ACNH Bun Bun. Is that Animal Crossing New Horizons? Yes, welcome, welcome. Thank you for following. And let's see. And Captive, you say you haven't heard of computer vision. And you say it sounds like a program that ties into a webcam that tries to process and identify what's being recorded. So that's actually, yeah, so that would be kind of object detection, where the objects in a frame, and what are the objects, object classification. And so Mr. Ed Makes, you say, finding ancient Aztec and Mayan ruins from aerial and satellite images. Okay, cool. So in that case, I think that would also be kind of object or pattern detection, pattern classification. And then Dano42 say, is it a subset of computer graphics? It is not. It is a subset of machine learning. And Caticle, you say semantic segmentation. Okay, so we're going to talk about that. I'm gonna use the broader kind of parent here and say object segmentation. And so this is where like we're asking which pixels belong to the object. Like, where does the object end, essentially? Let's see here. What else? Oh, one that I find really, really cool is change detection, because this is really, really useful for disaster response and humanitarian aid. So change detection is really, really important, which is essentially where's the change between these two images. So you can have, you know, an image, a satellite image of a city before a disaster and a satellite image of that city after. And you can use computer vision and other models to not only see what change is there, but to kind of predict the level of damage. And that's really, really important and very cool. And Bored Spaghetti, you say, would I say it's worth for physicists to learn machine learning? Well, okay. Look at my streams. I kind of want everyone to learn about machine learning. That said, I think it really depends on what kind of physics you do. I would say that learning a lot of the statistics and math, a lot of it you're going to know already if you do physics. That was at least one life hack for me switching into machine learning was I've never struggled with the math part of it, thankfully, because the physics math I've done has been way harder. But it really depends on what you want to get out of it, especially in more of applied physics fields. There's lots of research uses for machine learning. And so Algebra 97, you say, by saying computer vision, we just understand working with images as data, right? I mean, we can still use some of the supervised or unsupervised learning for this data. Yeah. And so we're going to talk about this a little bit because imagine that you do have an image. Well, we've talked about lots of different kinds of models, but how would you just, here's your image, like I'm just handing it to you, you know, do linear regression on that image. Wait, what? How? So a lot of the challenges with computer vision, or what makes it so different, is that imagery data is different from a lot of the things we've done before. And so it kind of is going to require some very different approaches, at least to process, just like we learned yesterday with natural language processing, right? Where switching from more numeric data into string or text data required kind of different methods and different approaches to be able to break that down, vectorize it, use it with a model. So regardless of what model you kind of slap on the end, computer vision does have to take some additional things into consideration. And Pime Now, thank you for following. And let's see here. Okay, yes, I think I got all the questions. Loafbone, by the way, tag Loafbone. He's your mod. If I miss a question, he will make sure that it gets highlighted and that I'll answer it. So sometimes chat goes quickly, or I get off on like a tangent about, I don't know, Dota, and then I forget to answer questions. And Severo, oh my goodness, thank you so much for those bits. Happy Friday, and thank you. Okay, so let's see. Oh, the other one that is kind of cool is pose estimation. So I've often seen this for like almost kind of the computer vision version of sentiment analysis, which is like recognizing postures as being kind of like angry or somebody seeming more open and doing like that kind of thing. But pose estimation can also be used in industry to kind of keep track of like mechanical arms, like doing things on conveyor belts or something. So it has a lot of uses. Pose, don't just think of human poses, which was, you know, the way I would think about it. But this is kind of the orientation of an object with respect to the camera. So this can mean a lot of different things. And let's see. And for tracking or predicting if someone is about to fall. Ooh, I like that. Okay, thank you, Tyler. That's a great one. So like fall prediction. That's really cool. I actually went, this is slight tangent from computer vision entirely, but I was, my brother had asked me, because there's a character in an anime he was showing me. He asked me about modern prostheses, like leg prostheses for people who have had above knee amputations. And I mean, I'm sitting there like, it's flattering sometimes, the questions he asked me, because I think he just assumes I know everything, which is like, I feel like a cool big sister. And I'm like, yes, I do know everything, but I don't. So I looked it up and I read up on a lot of different cool prostheses that involve having to have a prosthetic knee, because his question was like, how do people move around? And like, how do you kind of like have the, how do you have the leg bend, right? Unless it's connected to your muscles. And so a lot of that is done through very, very fancy prosthetic legs that have microprocessors in them. And then that got me like, they can do things like fall prediction. And so they're able to kind of like correct for incline, speed, gait, all of that, kind of do fall prediction, do like adjustments for like slippery terrain versus kind of, you know, more solid ground. And so it was really cool. And I was just like, wow, that's literally machine learning in someone's leg, which makes sense when you think about it. But I hadn't really asked myself that question of like, how do prosthetic knees work? Wasn't a question I had asked myself. And I thought, I don't know, I thought that was really, really cool. So you say your alma mater uses pose estimation for elder care. That's really cool. You know, and this is the challenge, and I'm sure Tyler, you can talk more about this too, but like as we've talked about, there's been a theme kind of going through a lot of our conversations about machine learning myths, which is often about the ethics of machine learning. And one of the challenges that lots of models that can be used for such wonderful things to help people can also be used for really like, you know, not good things that don't respect privacy. And I remember hearing this demo of software that was like it was like, I don't think it was the intention of the company to do this, but you know, there's, according to the laws, at least in the United States, you can't have like cameras in bathrooms, at least in a lot of different states. And so they were doing kind of tracking people, but they had a model that would be able to not only like track people, create like a 3D representation of the space. And so like if they went to the bathroom or something, they would still know they're in the bathroom and then be able to like track like their paths and when they came out. And it was just like, it felt a little, the example was employee tracking. And I was like, that feels a little bit icky. But I think like having something like that for a care facility would make a lot of sense. Like someone goes into a bathroom, like an elderly person, and it's been like an hour and a half, like maybe that sets off like some kind of alarm or something so someone can check on them, because that kind of stuff, like that's a really, really good application of that kind of technology that would help keep people safe. But let's see. And ooh, cool mechanical shoes that counteract loss of balance in elders. That also sounds really, really cool. Okay. So, oh, and codename SQL. Thank you. Thank you for the follow. All right. So, let's see. And one thing that might not occur to you is that all of this wonderful goodness that we just talked about, cool computer vision stuff, right? Because that's the technical term. Tyler's going to have a lot of correcting to do when he jumps on. But computer vision also can be applied to video. Because really, if you think about it, what is video but a sequence of images, a sequence of frames? There are, of course, more challenges to processing frames fast enough and things like that. That's a whole other challenge, but a lot of, like, all of this can be, if you can apply it to an image, you know, you can mostly apply it to a video. And JB Estrada, thank you for following. I know, so it's just funny, Tyler, having you in chat, because anytime I say something, I start to go, oh crap, like, I feel good on like the math, and I feel good on like the neural nets and everything like that, but I don't build CV models often enough to feel like I know this space inside and out. And board spaghetti, somebody else asked me that. So actually, Tyler, this is a great question for you. I hadn't personally heard of lip reading being a use case for CV. I don't, as a linguist at least, I feel like there's going to be a lot of challenges to that, because there are many, many reasons why somebody might talk a little bit differently. Also, you know, different accents and things like that. But it makes sense as a use case. I feel like that would just be really hard. Let's see here. Oh, I was formerly a linguist. I should say board spaghetti. Sorry. That was my undergraduate education. And let's see, Magnusine, you say, would you say that one would apply the dimension of time or time series analysis or derivatives with respect to changes in frames when applying these techniques from photo to video? It depends on which techniques, for sure. So when I have done it, it's been more less, I would say, like a complex derivative, to be honest, and more of a simple difference. Because a lot of times you're not going to have massive change between frames. But I think the way that you're thinking about it makes sense. I haven't really treated frames themselves as time series. It's been more about processing each frame individually, but there are probably lots of different ways to do it. And Board Spaghetti, you say, would you use machine learning for dead language reconstruction? Well. Pete Pan DeSalle, thank you for following. And you say, is there any way to recreate Proto-Indo-European? Oh, you're literally like, this is my happy place. You're asking me the best questions. Okay, so cool thing, right? Is so I took one of my graduate classes in linguistics was it was mixed undergrad and graduate, and I was like, I'm gonna take the graduate version. I was a tryhard, and it was literally on reconstructing Proto-Indo-European. And so it's really funny you say that, because I feel like you could, and I feel like there would be it would be challenging, but it'd be really interesting. Because if you think about it, like recreating Proto-Indo-European is based on an assumption, and an assumption that has a decent amount of testing, but still an assumption that evolutionary changes in language are systematic. And so we can kind of, with not 100% certainty, of course, and there's a lot of detail lost, we can still roll the clock back and think about, what that initial Proto-Indo-European that spawned all Indo-European languages might have sounded like. And if you've seen the movie, oh crap, what was it? It was like the Prometheus? Was that the movie? Is that a movie? It was like the prequel to Alien. And it wasn't Arrival, so I've got a funny story for that really quick. No, it was like the prequel to Alien or something like that. And I remember there's a small part where the android in the movie is learning Proto-Indo-European, and he starts to speak it. And at least when we were trying to speak it in the class, it sounded very, very similar. Oh, yes. Okay. Thank you for the waiting. Oh my gosh. Okay. Board Spaghetti. Oh, this is for you. Crap. What's the link? Astro? Yes. Board Spaghetti. I wrote that, and I got to interview the author, Ted Chiang. I got to interview him. And, oh wait, is Simuleos here? I have to wait, because it takes a while for the raider to join the chat, and I don't want to say, like, thank you and everything when he's not here. Yes, okay, hi, yeah, I saw you raided, but, like, I try to wait, because a lot of times it takes people a second to get into chat, and sometimes it's happened that I'm, like, so excited, I've been, thanking them for the raid, and they miss me thanking them, because it took them a second to get in, so I try to wait now. But thank you so much for the raid. How are you? And yes, Icy Yogi. Yeah, okay. Arrivals Linguistics. So this is that paper, or that article that I just linked was my undergraduate thesis combined with getting to interview Ted Chiang and talk all about Arrival. So it kind of was this wonderful, like, smush together of lots of my favorite things. But it was a really cool experience, and I also got to talk for pages about my thesis subject, so it was really neat. And yay, okay, everyone's excited about that. Good, okay, because sometimes when I'm streaming and somebody asks me and I'm like, yeah, I got to interview this person and like this, Arrival, and they're like, I don't know what you're talking about. And then I'm like, oh man, I'm cool to some people, I swear. Oh, thank you, Icy Yogi. I'm glad you enjoyed it. And yes, I'm so glad we have raiders here, because we just started talking about computer vision, and it's gonna be a good stream. So let's see here. We've talked a little bit about kind of tasks in computer vision, but in a lot of our machine learning tasks, or a lot of our machine learning models and our approaches, one of the key kind of steps has been feature extraction, right? So what might you think are some features when we're dealing with images? So it'll depend obviously on the task, But since you know, previously, for a lot of our early models, we had our features kind of handed to us, right? It was a little bit easy. We had to do some feature engineering and we had to do some cleaning and things like that. But it wasn't until, I would say, probably NLP yesterday where folks began to see that sometimes it's not clear what your features are, and you have to make, like, you yourself have to make a decision about what features you're going to use. So what do you think are some features in CV? And let's see, any good textbooks on, oh, I have an entire like bookshelf. So I will send you a list. If you're not in the Discord, join the Discord, because that's the easiest way for me to send people things. Ones that you can reliably get, none. Okay, so color, that's an interesting. Okay, so color might be a feature. Topology. So what do you mean by that, Andrea Polari? Geometry. Okay, so things like shapes or lines, maybe. I love that you're just like, there are none. And all the people trying to learn CV are like, let's see. Pime now, you say, what framework do you usually use for machine learning stuff? It really depends on what kind of machine learning. Brightness, okay. I'm gonna make this all in a straight line. Borders, I like that. Yes, borders. So another one here might be corners. And movement. Okay, so movement would be change, right? And okay, you said you'll explain later. What about but feel free to tell us some cool features that maybe we're not thinking about, Tyler. With the understanding, of course, that it sounds like it obviously is not reliably always there. And Amaras37, thank you for following, and have a good night. And yay, thank you for following, Board Spaghetti. Welcome. So what else might we be able to use for feature extraction? So what kind of features might we be interested in? Yes, textures. I was hoping somebody was going to say that, which I thought was really, really cool. So it's interesting, right? Because again, we're having to think a little bit differently. So textures, at least the way that I've seen it, and so Tyler, you can correct me, is more like patterns. So instead of like looking for a square or a line or a corner or a curve even, textures are more about like kind of patterns more, right? So I'm trying to think, like if you have an image that has a bunch of trees, like the leaf pattern, like the pattern of the leaves and the trees is going to have a different texture than, say, the smoothness of the bark or how smooth like concrete is or something. So yeah, texture in the 3D modeling sense, that's a good way to think about it. And so let's see what else. Yeah, exactly. So it's not textures. I guess textures can have a lot of meanings based on what discipline you're coming from. But hi, Katya Zeros, how are you? And Uwakumi, thank you for following. So that was particularly interesting to me because I work with the CV stuff that I've done is more like in the remote sensing kind of sense, or in like the astronomy sense, which tends to be very, very different than a lot of other applications of CV. And textures is really, really important. So especially when we're looking at things like galaxies, for example. Yes, you learned how to use pandas today. Awesome. That's so great. And Zombie Bober. Did I get that? Zombie? Yes, Zombie Bobber. Thank you for following. Ah, that's awesome, Katya. Pandas is a great library to kind of get started with data science. There's lots of cool stuff to do there. So, yay. If you're not in the Discord, join already, because I have a lot of good resources for kind of getting started with Python and data science. And Tyler, you say you too, just not pointed at space. Exactly. And Detox Mango, thank you for following. I do really like CV for space because it's really hard. It's like super, well, CV for everything is hard, but space is like really hard. It's really, really cool when you think about something that is so intuitive for a human being to look at like a picture of a galaxy and go, yep, that's a spiral. Getting a model to do that consistently is incredibly hard. And Kark, you say you want to do some data science, but not Python. There's lots of other great languages to do data science. I would say that if you're interested in machine learning, Python is one of the most common, but there are a lot of other great languages that you can use as well. Katya Zeros, you say, must be immensely satisfying to model a spiral, though. Well, who here remembers the galaxy, the structural modeling stream that I did? Because you say it would be fun, and then it can be it can just be the most frustrating thing. Yes, okay, I'm waiting. There's a raider. I will wait until the raider has... Oh, wait, no, he's already in the chat. Hi! Thank you so much for raiding, Melky Dev. And welcome, raiders. We are talking about... if you didn't already know, we're talking about computer vision. I was just explaining that computer vision applied to astronomy is in particular very, very difficult. And even just a simple task like what we would think is a simple task, like classifying galaxies, gets really hard. And Carl Vandergeest, thank you for following. And you say your master's and I was in computer vision. Well, welcome. So I will introduce you then to Faultline in chat, who is my colleague who will be joining me later. He also, I think, master's in CV, and I think you're doing your PhD now. Anyway, I forget. Like, he's got a gazillion degrees in whatever. But super smart, also does CV. He's my resident CV expert that I go to when I'm like, oh, what's going on? Because I don't do a lot of CV. So, awesome. Now we have a bunch of CV people who know what they're doing in chat. Great. Now if I make a fool of myself, everyone knows. No, I'm joking. Oh yeah, I used YOLO v3. So I did YOLO. I used that for object tracking as well. So that was one of my few CV projects. But it was really, really cool actually. My favorite thing about YOLO is when it messes up though, because it's hysterical. And actually I'll show you all the video. So for those of you who don't know what YOLO is, give me a second here. Because his site has a video. YouTube video. Watch on YouTube. Yes, please. Can I watch on YouTube? Yes, I would like to skip the ads, please. Okay, so if you're curious, so this is V3, but theater mode. I guess I just make it huge so everyone sees that, right? My head might be in the way, and we'll mute this. No one needs the cool music. And Sweep, thank you for following. I actually don't know if YouTube's gonna get angry at me for this, so I'll figure it out when I'm posting the VOD on YouTube. But so this is the model that Melky Dev and I were talking about. But I love watching when it screws up. Like there's one where there's a woman with like I think a giant like falcon of some kind. See, like it's confused if that's a dog or a teddy bear, which I just think is hysterical. I love this so much. I love when it messes up and the ways that it messes up. And good night, board spaghetti. I just sometimes that to me, like I'm sure for people who do CV all the time, it's frustrating. But like I think it's not sure what that is. It's like it's a dog, it's a person, it's a dog, it's a dog, it's a person. I love that. And GACBL, thank you for following. So those of you who have been here, you experts in chat, you shush for a second. But what computer vision tasks is this model doing? So we kind of introduced a bunch of different, computer vision tasks. What do you see this model doing? What kinds of things is it doing? And Liberated Apathy, you ask, can this be done in real time? So in real time, like as in you're feeding it live video, I mean, the model training, at least for YOLO, when the data set I was working with did take a chunk of time. So you have to have a pre-trained model, of course. But yeah, it can absolutely be done in real time. So yeah, algebra, you say classification. So we've got object classification. So it has to be able to tell there's an object there, and it has to be able to classify that object. And so yeah, we have tracking as well. It's tracking the object throughout different frames. And what about these bounding boxes? What's going on there? I know, I love, is it not actually tracking? Is it just looking for the same, it's repeating the identification between frames? Yeah, okay, that's, all right. Yeah, so it's just, it gives the illusion kind of, I guess, of tracking in that sense. When I used YOLO, we were doing it for quote unquote tracking. So I guess the distinction there being the computer vision technical term of tracking versus our approach, which is rerunning the classification on each frame. And yeah, I know, Needy Only, isn't this really cool? And Campbell is a combination between a horse and a cow, who knew? Right? So sometimes the ways that it's misclassifying things are really, really interesting. And so I find that really, really cool sometimes. So it struggles with different things, like so also you have to think, right? Those of you who've been here for a bit, you've done multi-class classification with me, right? Like, let's say you wanted to create this kind of model to be able to identify all of these different things. Like, what do you think you would need, right? Well, we've talked about classifying, I mean, I think we've done like 3 or 4 classes, but like this is a lot of different classes, right? You have all of these different animals. Like, that's also why it's screwing up sometimes, is maybe it doesn't have this class. Yeah, and fault line Tyler is absolutely right. Millions of images. Ugh. But anyway, so that's an example of some of the things we've been talking about, and that was the YOLO model that you saw us discussing in chat. But it's a double cow. Lots and lots of data. Lots and lots of data. Okay, so let's see here. Well, I've been talking a lot about an ATX Pete. Thank you for following. Okay, so, and several, I think that is a good Tyler question, because at least for me, our hacky way of approaching tracking was to just redo classification for each frame. So if there's like a fancier way to do it, Tyler, or a more authentic way to do it, Tyler will know. Yes, we can come back to it when you're on. So we'll save that. We'll bank that question. So remember that, Severo. But one of the things that one of the approaches here to we're gonna need neural nets, essentially, is where I'm going with this. But the first thing is to think about how you take an image and you represent it as data. So this is something that might not be intuitive at first. I remember many years ago, the first time I worked with astronomy data, that it just was like oh wait, I guess that makes sense, that we can represent an image as an array, right? So image, we can represent an image as an array, and let's say for just now that we're not going to deal with color, but each value here would be a pixel value, right? So I don't know reasonable pixel values here. So if we're just like making up some numbers, whatever. This is a very small image, clearly, but I'm just giving you an example, right? And here are the indices of our array are talking about that pixel's position in the image. I meant like reasonable values for like what an image might have, and I just made up numbers. So like this probably would look really weird if I turned that into an image. But Risky Banana, you say you are working on some dodgy ML to sort and store CSV files. Oh no. That sounds interesting. You'll have to tell me about it. All right, let's get our holiday music back. Okay. So this is how we might take an image and convert it into a form that's you know, that can be used with a model. So are we done? We just feed this to something. this is where it gets a little bit more complicated. Because just like with our text data yesterday, where we had to do all of those different steps of breaking down the input into something that's really useful, we have to do some of those steps here. But Ian Alex Hart, thank you for your bits. Okay, all right. You know what? I think before we get into the convolutional neural nets, because that's quite a chonky thing to discuss, let's do a dog break. Let's do a dog break. So give me a quick second to get it up and running. And we'll give the dog some treats, because you know that's our reward for an hour of stream. We've talked a lot about NLP and also quite a bit about computer vision. But before we get into the more neural nets, which is really fun, we should give the dogs some love. And Ian Alex Hart has banked so many treats at this point that we got to make sure we pay out and we give the dogs what they deserve. Good treats for these good boys. And Detox Mango, you say, does a brain surgeon usually know neural networks? You will have to ask a brain surgeon. Actually, next time I have Alice on stream, my friend who is the marine neurobiologist, she'd be a great person to ask, because we were talking about some very similar approaches and terminology, but obviously I think neural nets, the artificial neural networks, are inspired by biological neural networks, but they are not the same. So inspired by, there are some similar language used, but they're very different. Okay. So, oh no, I started giving treats before I turned on the, hold on, here you go. And thank you, Narco Says, for following. Let's see if I can get Hubble to come over. Come on, baby. Come on. Oh, there he is. Good treats for a good boy. And hi, Narco Says, welcome. So this is Hubble, for those of you who haven't met him. We like to take brief stream breaks sometimes when we get lots of bits, and we give the bits back to Hubble in the form of treats. So Hubble is a fan of the stream now. So he is extremely excited for treats. I really want to see if I can get him to catch them, but he's not quite there yet. It's still, I think, the Furbo's still something he's getting used to. I know, Hubble's a very good boy. He's also our emote. Such a very good boy. Wait, is that nice slow phone? And no worries. Yeah. Have a good night. Thank you for following, Narco Says. I have no idea how many treats I've given him, but he deserves a little bit more, and then we'll get to convolutional neural nets. This is our reward. I was wondering if that was a Templar Assassin emote, emoji, whatever. The treat is launched. So, oh my god, the little head tilt. Okay, one last treat, and then I'm cutting myself off because I could do this forever. Doesn't it? Okay, is it not? I thought it, okay, it looks quite a bit. And that noob, thank you for following. Okay, one last treat for Hubble. Oh my god, he's so perfect. I love my dog. Oh, Templar Assassin, what did I say? What did I say out loud? Did I say Phantom Assassin by mistake? Sorry, I was thinking about Hubble. TA's who I meant. Oh, okay, I did say it. All right, I did say it right. I was like, oh god, I thought you were correcting me, and I was like, what came out of my mouth? That's always a great feeling on stream where you're like, what did I just say? And you can't remember. Okay, that's actually the last treat. I gotta stop. He's a very good boy, but y'all are here for the convolutional neural nets and not my dog. Okay. So, all right. So we were talking about how can we convert images into a form that we would be able to use with machine learning models. Now, again, those of you who know all about CV, this question is not for you. But for those of you who have been here for, the Neural Nets 101 and how we applied neural nets to reinforcement learning, what might be a challenge of taking this array that is our image and feeding it into our, I'll do a little like graphical representation here. This is not supposed to be accurate. whatever, into our neural network. And those of you who were here for the graph theory stream will remember that this is just a bipartite graph. I will make all my connections. I will do it. I will do it. It's very ugly, but who cares? All right. Oh my God, he's hitting the treat thing. And is he sitting? Oh no, please don't sit. I can't resist him when he sits. Hold on. No, he's not sitting. Okay. Phew. He does this thing where he sits all weird and awkward, and it looks really cute, and then I have to give him treats. But Kark, thank you for following. Calico, you say dog 82%, neural nets 11%. Fair enough. That's fine. If you're here for the dogs, that's good too. But okay, so what might be... Oh, yes, Justice Good Joe. I'm so glad you're here. I actually, when I was writing the notes for this stream, put something in there just for you. So I was hoping you would show up. But, all right, so what might be some of the challenges of doing what we consider our conventional neural net, right? So the neural nets that we've discussed, nothing fancy, but what might be some of the challenges of maybe just going, okay, we're just going to feed this into our neural net. Why might we have trouble here? Wait, what? Oh, Kark, you say you want more of these streams? You want to learn this stuff? Yes, in case you missed out on it, I've done the 12 days of machine learning, miss. So if you go to YouTube, all of the topics that I was referencing earlier with the schedule, if you were here for that, you can see all of the VODs for those streams, the code, the notes, everything's on GitHub, and the videos are on YouTube. So if there is if there's a concept or a topic that you'd like, I would recommend starting there. And Olims, you say greetings from Montevideo. Thank you. If I screwed that, Montevideo. I don't know. And Diraj, you say hydrate. You're right. My voice is getting a little scratchy. And you said you're about to ask if something like that exists. Thanks for reading your mind. Oh, the YouTube? Yeah, of course. And David3 Chorvath, thank you for following. So this, honestly, it was a learning experience for me because my streams are usually much, much smaller. And so when I kind of planned out the 12 days of machine learning miss, I kind of envisioned it would just be my usual community and, you know, it'd be great, right? It'd be fine and the VODs would be up for a little bit. But the first few streams especially were so much bigger and people were asking like, I missed yesterday, like, what happens if the VOD goes away? Like, can you put this on YouTube? So, made my first YouTube channel, started putting the VODs on YouTube, and then there was like request for the Blackboard images, for a lot more resources. So I've learned a lot from it about what people want from these streams. So hopefully now that I've done 12 of them, 11 and a half, they're getting better and I'll be able to give you guys more and more useful content. And greetings, David3 Chorvath. Welcome. Okay, so what are our issues here? And giving you a hint here, I've given you a very small image, but even if we just use a, I don't know, like 100 by 100, let's say, pixel image, 100 by 100, this is our example, label that. So people are like, what are all these hundreds doing? All right, so this is our image, right? Start to think about this practically, right? So think about the basic, you know, feed-forward multi-layer perceptron network we built with the Neural Nets 101, right? What's our process here? If we have an array and we're going to feed this into the first layer, our input layer of our network, what do we do? What's that going to look like? Because there's going to be, I think it's going to become, when you start to think back to that and think about how you would do it practically, you'll start to realize why computer vision has to do things differently. And that's how we get the convolutional neural nets. So what would be the challenge here about having an array of 100 by 100 values, and we're not even talking color yet, but feeding that to our neural net. Think about it. And thank you for following X Trigger Finger X. People's names. The curse of dimensionality. In what sense, MH Zanierman? So you're right. Like, we're going to have an issue here with dimensionality. And this is quite a small image, right? A lot of the images that I've used are 10,000 by 10,000 pixels, for example. But so I think what I'm trying to kind of lead you to see here is that if we're putting this in, yes. And so Krieger Sorcerer X, you say each pixel's RGB. So yeah, so if we have color too, we have like 100 by 100 by 3, right? But remember when we have fed arrays to our neural nets before, and Makakofonico? Oh, that was a rough one. I'm sorry. Welcome and thank you for following. So when we did it before, right, for each of our kind of like feature vectors, or for each of our features, we would have a neuron in our input layer. Here, okay, so we also are going to need all of those to be fed then to, you know, each of the following. Okay, so now we've got, let's see. So if we're counting our weights, we've got 100 by 100 by 3. So that's going to be 30,000 weights for a single neuron in our first hidden layer, at least. Like that gets problematic really fast. And this is a small image. This is 100 by 100 pixels. So already we're kind of getting to a like, okay, this is going to balloon up really, really fast. So what do we do? And as a gentle reminder, especially if folks are new to neural nets and you weren't here for the neural nets, remember this is our neural net stream. This is our input layer, right? Then we got some hidden layers a lot of times. Hidden layers. And then we have our output layer. And remember that, you know, when we were doing it, we talked about how we have the dot product, right, of the input vector and our weights plus our bias, and then that gets fed into an activation function, and that is the output. We're gonna look at some different kinds of layers today, but those are just some, you know, our loss function, let's see, backpropagation, all of that we talked about in Neural Nets 101, and we built from scratch. So see that video if you are interested and want to learn more about neural nets. But today we're gonna do something different. So this is, because of this challenge, we're gonna need a special kind of neural net. And these are called convolutional neural nets, or CNN. And so if you were also here for the anomaly detection stream, you'll remember that I specifically wrote composite nearest neighbors with a small c to distinguish that from convolutional neural nets. But still, lots of people do it with a capital C, so depending on what machine learning paper you are reading, CNN can mean something very different. Okay, so like I said, convolutional neural nets, they're kind of like designed to deal with images. So if our previous approach was, I'll redraw that here. So if our previous approach is like, let's say we've got this as our input layer, and then we have some hidden layers, and then we have an output layer, and then draw these very quickly. I'm not very good at drawing these things, but I think it's better than it was the first neural net stream, because that was a challenge. And all the graphs from the graph theory stream as well. I got practice drawing lots of circles. Oof. All right. Okay. So we've got our input layer, hidden layers, output layer. This is what we know. And I'm actually going to erase CNN here so that it doesn't confuse anyone, right? So this is our normal neural net. So this is what we've learned so far. Now, and this is super cool, and actually there was somebody in chat who was sharing a simulation of neural nets, and it would have been really, really helpful to have here, because if you think about our input when we have an image in color especially, right? Oh boy, this is going to require some drawing. Stay with me, friends. I'm sorry if it's awful. So we have an image, right? And the way that we show color is we're going to have color channels. So there's going to be an image that's the red values, an image that's the blue values, or an array, that's the blue values and green values. And so really what we're talking about, oh God, I'm not an artist. Oh no. Okay, it's fine. That'll work. Is we're talking about a three-dimensional structure. And so our neural net should be able to use that. It should be able to, work with that particular data structure. So it's our input, okay? And in this case, this is gonna be our input layer. And our input layer will have dimensions of the width of our image times the height of our image, and assuming RGB 3. Our depth will be our color channels. And so our hidden layer then, instead of having these kind of two-dimensional layers, we're going to have me draw something else. Couldn't find the YouTube vid? Okay, that's all right. Thank you for looking, Lovebone. Oh, I'm trying. Close enough, right? All right, so this might be one of our hidden layers, for example. So our data, we need to have this kind of three-dimensional structure here. That actually looks quite bad. Let me fix that. Because that's really what our input is in. Thank you, Tyler. I have a reference image, but I decided to change the perspective when I was drawing this for I don't know reasons, and so now I can't, it doesn't help. And so just like this is going to have a width, a height, and a depth. And eventually, regardless of how many layers we have, however many layers we want here, the output that we want, because remember in this case I'm talking about classification. So let's just have that. We're going to have, oh God. Let me think about how to draw this. Yeah. No, I still did it wrong. I really want it to be horizontal, but I don't think that actually matches. So we want a who knew this was going to be an art stream? Then our output is going to be a 1 by 1, that's not a 1 by 1 by n, where n is our number of classes. And so one of the reasons that our traditional, our normal neural net is going to struggle, right, were those number of weights. And so here you might be going, well, don't we still have the problem with all of the weights? Well, so this is a really, really cool thing about convolutional neural nets, is that instead of having a fully connected, what we would call a complete, right, our complete bipartite graphs from graph theory, instead of having a fully connected network, instead our neurons in our next layer are only going to be kind of connected to a small sort of sub piece of the image. And Sundari Tuber, thank you. Oh my goodness, I was trying so hard. And Definite Optimist, hi, welcome. And so we're going to talk about what all this is in more technical detail, but I wanted to give you at least some conceptual visualizations for how this is changing. And thank you for following Definite. Definite, did I get that right? Yeah, Definite Optimist. So you can see that also, wow, I should have kept the colors to be the same so you could... Sorry about that. I just got overly excited about the colors. But nevertheless, we're going to dive into this architecture in more detail, but I wanted you at least to be able to kind of see that we're going to be dealing with very different structures than we did in our kind of normal neural net. Is this what the CC turned into? What? Sorry, I read CC as closed caption. Are you talking about something? You're probably talking about something else. Okay, so let's talk about this in more detail. So convolutional neural net architecture. So I actually should probably use the sparkly pen because this is a new section. Architecture. Okay. Autobots roll out. All right, so let's say that we want to build a model. And our model's like, it's not the best computer vision model, all right? But it's a simple one because we're just starting out. And we want it to be able to identify straight lines in an image. Okay. So what kind of straight line might we want it to identify? So let's see here. So let's say this is 5, 2, 3, 5. I have someplace I'm going with this. Hold on. This is not just like a weird zero matrix. I'll have this be this. So if we were to kind of draw a straight line, maybe this is what our image would look like. And Magazine, you say you're heading out? Oh yeah, of course. Thank you for stopping by. Have a good night. Okay. So, if we want to build a model to identify a straight line, this might be kind of like the straight line that we're looking for. And if I were to terribly try to represent this as an image, maybe we'd have like this. Obviously, this like ratio of pixels is not right, but you don't want to sit here and watch me draw out hundreds of zeros. So we're gonna use this as our representation for at least for right now. And so if you can imagine that we have an image though, maybe this is our source image. And our source image is going to be my feelings about this week. This is our source image, right? And so, you know, if we were to, actually, let me make them match. So, okay, that's our source image. And so if we were to look at this as a as an array, oh, I started out making those way too small. 2, 3, 4, 5. So maybe we have, I don't know, 50. And then zeros. And then we've got 50s here. Okay, not perfect, but so let's say that this is our representation of this particular image. And we want some way to identify places where this straight line occurs in our image. I know the image examples are really, really simple, but this is going to at least hopefully give you an intuition for what we're going to be doing with the first kind of layer that we're going to learn about. And so I think you can see that if we do element-wise multiplication between these two arrays, right, what would we get? Oh, and look at that! Because blue and yellow makes green? Oh, yeah. We would get and then and let's see, 20 times 50 is 10,000? Oh my god, I'm really tired today. Yeah. Yeah, no, 2 zeros and then 10. So, no, yes. Someone help me. 50 times 20. I feel like 1,000. It is 1,000. Okay. I was sitting there going, that seems too small. But whatever. Numbers. All right. Add it a 0 because, you know, I'm an astronomer and that's fine. That's close enough. Definite Optimist, thank you so much for subscribing. Thank you for supporting the stream. All right. So we might get this, right? And that would give us just this, right? Just this horizontal. And so this would be one way that we could try and detect whether or not this particular line is in an image is if we multiply, and multiplication here I'm using very, very generally, like we'll talk more about the math in a minute, but we would have really, really large values where that particular structure exists in our image. And so this is essentially a very, very basic but conceptual approach to what we're going to be talking about with our convolutional layer. And let's see here. So let me actually give a Mohammed Carpet Bomber. That's quite a name. Thank you for following. And so really what we're doing is this is going to be called our filter. And we're going to convolve that filter with our input image. So this is our input image. And outward, we're going to get something that is going to, depending on, there's a couple different things you can say. I've heard feature maps, I've heard activation maps. Activation. I like activation map. Sounds cool. And this is our activation map. So now if you think about it, what happens if, actually there's an important part of this though, and I mentioned this a little bit earlier, which is that one of the cool perks of using a convolutional neural net, right, is that it's not going to need to have all of those different connections, right? So we're able to look at small pieces of the image at a time. And so really what this is going to end up looking like, this was a very simple example, but really what this is going to look like is, let me see if I can draw this. How do I want to draw this? So yellow for input image. Okay, so. So really, what our filter is going to do is our filter is going to have a certain size, and that filter is going to look at a certain area of our image, right? And just like what we talked about previously, this should feel very similar to what we were doing before with some of the processing in our neurons. Is that it's going to do that dot product, right, from the input and the weights, and then it's going to sum it, and so we'll get a certain number out of that. And so not only are we getting a single number from, in this case, 25 pixels, but it's also going to be giving us kind of a measurement almost of whether or not that structure is in that little sub portion of the image. And as we move this filter across or convolve this filter, it's called convolving, we'll be kind of moving. There's all kinds of tuning or like hyperparameters you can change here. So you can like make it go over 1 pixel at a time, 10 pixels at a time, whatever. But for the sake of argument, let's just say 1. And we're going to say this is 100 by 100. And our filter is going to be 5 by 5. And Nirat, thank you for following. And so what we're going to get is, this is 5 by 5 by 3. I should have specified, and 100 by 100 by 3. And so we are going to have 75 multiplications that are going to sum up into our number. And then what we're going to get out of this would be I need to change my colors again, a 95 by 95 by 1 array. It's not really a convolution in the mathematical sense, right? But if they go out and they read any of these like intros, that's how they describe it. So it's the juggling act of like, you want to remain technically accurate, but also prepare people to go out and read more about it. So that threw me also for a second, to be honest, because when I was like reading some papers and I was like, oh, like convolution in the mathematical sense. And then it took me like way too long to realize that it was just the term that they were using for sliding this across it was, yeah. So, but that is a very good point, is that we're not talking capital C convolution in the mathematical convolution sense. Yes, non-dairy neutrino, thank you. Sliding windows. We're sliding. Yes. And Tyler also brings up another thing, is when I was talking about, oh, you can set whether or not you want it to move over by 1 pixel or 2 pixel. That's called the stride. So that is what, see, yeah, no, you're fine. You see the sliding part is in the convolution part. I can't tell you how many, like, articles I've said that literally say the sliding is the convolution part. So I'm not saying I trust you more than I trust other articles. So, in any case, all right. And no, you're not distracting. The whole point is like, this is not like a lecture or anything. We're all just hanging out talking about arrays for fun. Okay, and so this, you know, our 95 by 95 by 1, this is what I was saying right there. This is our activation map or a feature map. And this particular process, this is our convolution layer. Now, a lot of times, these convolution layers are going to be stacked, and they're going to be throughout the whole convolutional neural net. And this is something that I just think is super, super cool. And I wanted to find a good image. I don't know, Tyler, you might have a good one to demonstrate this. But as you move throughout these layers, your filter and where tag, thank you for following, essentially what your activation map is going to change. And as you move through, it's essentially going to start to represent more and more complex features. Because obviously, especially if we want to identify dogs, we don't just want straight lines. We might want even more complicated features like ears or tails or size or snoots, you know, important parts of a dog. And so we're going to need these layers of our convolution layers as we move through this process to start to represent more and more complicated features. Identify hot dogs. Haha. Is it 96 by 96? Did I do the... Yes, you're right. Thank you. This is what I get for possibly multitasking some of this while in a meeting. Okay. And no, there's no stupid questions. Seriously. It's good. It's great. Can we identify not hot dogs? Identifying the lack of something is way harder. Okay, so the thought process there is that as we move this 5 by 5 matrix across, right? So we can have it here, 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 all the way down. The last place that we can have it is, no, it's 0 to 95. Right? What am I missing? Because the very last place it can be at is 95. No, I think I was right. I think it is 95. And Dauberson, no, so the activation map and the filter are different. So the filter is, I will scroll up for a second while we're trying to figure out whether or not I'm off by 1, which, classic, right? The filter kind of represents the way that I like to think about it. Yeah, so I thought 0 to 95. Oh, inclusive is 96. So am I... So yeah, okay, that's the 96 then. Thank you. So you don't do this math by hand unless I have to. I know, but I was trying to like come up with good examples for stream. So I thought, oh, I'll just do it with 100 because the math's easy, right? So here your filter kind of represents the weights that that are kind of tuned to the particular structure or feature that that you're looking for. And yes, okay, yes, all right. So is 96 length? So I'm sorry, when I wrote the 95, I was thinking about it in array indices, not in length, and that was my fault. So I apologize. And you want to do your dot product with your input image, and then you get your activation map, which represents kind of almost like whether or not that feature is present in that little piece of the image that we have zoomed in on. Okay. So what made the array index 95? So if you think about where we can place this, right? The last place on this 100 by 100 image that we can place it is going to be going from, like the last one will be at index 99, and it will go back to index 95, and that's the last place. Like we can't scoot our filter any more to the right, because we run out of image. Oh, what made me think in finishing index keys rather than length? Because I just thought 100 minus 5. Literally. Sorry. Like, I was just kind of doing it very quickly, and it was my fault. I didn't think it through. So, yeah, it was just 100 minus 5. So, gotta remember that our indices work differently. Also, we need music. Okay. Alrighty. So, we're going to have some other kinds of layers. So, you also might see pooling layers or pool layers, though I guess, and Tyler, you can correct me. From what I was reading, these are way less, they're being phased out. They're not part of the cool CNN club anymore. But pooling layers, if you do see them, are about downsampling. So they're a great way to have fewer parameters in your future layers and also avoid some overfitting. That's news to you? Okay, well, according to the internet, pooling layers aren't cool anymore. So I was like, okay, well, I don't want to teach people like outdated stuff, sitting here feeling old, but okay. It's bad enough, like, yeah. Well, things change a lot in machine learning. Okay, so, oh yeah, and so Just As Good Joe, are you still here? Because this is also for folks who are asking about artificial neurons versus real neurons. I found this this cool image, and I thought it's also good to remind people. Yes, okay. So for folks who don't remember, because the next kind of layer I was just going to mention is like there's layers that just have activation functions. The pooling layer, for example, is not going to have like trainable weights, so it's going to be that's going to be a little bit different, right? In our previous neural nets that we've built, we had weights with everything that we needed to tune. Hi, Generic Crew. Speedy drop by. No worries. It's good to see you. So I saw this really cool, I'm going to try to like view this and draw this not terribly, because it was trying to compare essentially the activation function process with a neuron. So you'll have to tell me how inaccurate this is, Just As Good Joe. So if this is our cell body, okay, and we're going to have, this is the axon from a neuron, which is, what is that? That's like, is that, no, the dendrites are the branches at one end, the axon's the bit at the other end, right? Ooh, it's been a long time since biology. So axon from a neuron, okay? And then we have a synapse, okay? And then we've got the, yeah, no, that's the, or is that the body of the neuron? Anyway, whew, you're right. It's bringing me back. All right, and then we have the dendrites, which I do remember are like the root looking bits. Axons are the middle part before the dendrites. Okay, so that's what's covered in the myelin sheath. And repulverizer, thank you for following. Okay, so for us in machine learning, and actually, hold on. I'm missing another part, the output axon. Well, the output axon sounds really cool, so we're going to make that sparkly colors. Output axon. Okie dokie. All right, so if we were to translate this into machine learning speak, right, this is going to be kind of like a little bit of our input. Our synapse would be, oh, I got to change colors again, our weight. And then we would have, I made that purple. So this would be our dot product between our input feature vector and our weight, or weights. And Kalish 1, thank you for following. And then we would also have other connections that are like less cool. So, well, less cool. They're just not important for this. So we would also have, you know, all of our other wonderful goodness, blah, 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 right? Okay. And when this goes into our cell body, I know, doesn't the output axon look pretty cool? If you make it sparkly, anything's cool. And in our cell body, this is where we do our summation, right? So this is where we sum all of our weights and all of our inputs and weights. And we add our bias. And we feed it to, oh, I can't use the sparkly pen again, color. We feed it to our activation function. F, because it's a function. And then, oh, yes, I do get to use the sparkly again. For our output here, we would have what? This is where we feed. Oh, no, that's the galaxy pen. No, not you. This is where we feed this sum, right, into our activation function. So this is the activation of our neuron. And so I thought this was cool because it was like trying to take the actual neurological structure, I guess, and like map it to the artificial neuron. So I don't know, Just As Good Joe, if this is like actually accurate with the neurology. But I thought it was at least a cool representation. So when I saw that, I saved the picture because I was like, I have to show Just As Good Joe and ask if this is like neurologically at all accurate, because it was weird because like usually when at least especially when I'm teaching like neural nets 101, go back and see the video, right? Like it's inspired by biological neural nets, but like inspired by is kind of where it ends. And so it was interesting to see somebody like trying to make it fit the structure of biological neurons and those interactions. And let's see, definite optimist, you say you get a sum to activate a function which passes whatever activated it into itself. So yeah, you pass this sum into the activation function, which kind of determines the output. So if you want to know more details about this, I would definitely watch the Neural Nets 101 because we go through this in lots and lots of detail, and then we code from scratch a really basic network, but still. So in any case, we'll have to have Just As Good Joe tell us how accurate this is, but I thought it was cool. It is a cool representation. Yay, good. I thought you would like it. So here you go. I'll put purple. I haven't used a light purple in a while. Ooh, gold. No, gold. No, purple. See, this is for Just. Oh, do you have capitalized? Yeah, you do. Just As Good Joe. This is for you. All right, cool. So now back to convolutional neuron. That's the point. So the last layer, where W say machine learning is for nerds. Ah, yeah, it is. The last layer, so we've talked about convolutional layers. I've mentioned there are layers that just have like the activation functions. There can be those pooling layers which downsample. You can also, usually a lot of times, and I'll show you some structures that are different, but we'll have a fully connected layer. And so I've seen that abbreviated FC. And so all this does is this takes an input from a previous layer, right? So you could think about it maybe taking in a really complicated activation map, for example. And it outputs the string cheese thing I drew. So it outputs that 1 by 1 by n matrix. N is the number of classes. And that has our class probabilities. Abilities. There we go. Okay. So one thing to be careful of, that's probably a good write-up towards data science, seems to be decent. They do eventually have a paywall. So I've been trying to, as much as possible, keep not linked to stuff, because I find it, I don't know. I don't like paywalls with education. Gamer85, thank you for the bits. Oh my goodness. Thank you so much. Welcome. And let's see. So like I said, this is going to feel a little bit different from what we did before, because previously all of our layers had weights, and here they're not going to. So when you're thinking about like that, you know, that forward pass and that back propagation step for training, this will be a little bit different. And Definite Optimus, thank you so much for the, people are those bits for Hubble treats? Because sometimes people get really focused and they just want to cheer the content and they don't want to take a dog break. So I will let you, I've started to avoid them as well. I just remember I had recommended it to a protege of mine, and she ran into the paywall and was like, oh, is there a way around this? And I was like, oh God, I'm sorry. I just mentioned this is like one of those blogs that I thought was out there that covered machine learning stuff. You want both? Okay, dogs. You got it, folks. You got it. Oh, and I've got a treat for you. We've got both dogs right here. Get excited. So this is Tennessee. He's the one that sings for you. So a lot of times, if it's not too late and I have energy, which hasn't been the last few streams, oh, he's limping a little bit. That might have just been him getting up. Poor little bean. Tennessee does not seem to give any shits about the treats. But Tennessee is the one who sings for you at the end of stream. So he sings sci-fi themes. He sings some video game themes. Okay, he's peacing out. Bye, 10. Wow. Okay, Tennessee. Jeez. All right, one more treat for Hubble. And of course the Christmas tree is still up. Please. There are presents still under the tree. My parents growing up were Russian Orthodox, and they celebrate Christmas on January 7th. So I just got really accustomed to having the tree up for probably way longer than most people. I'm sorry, baby, you get one more treat, but then I'm cutting you off. You get one more treat. Oh my God. Because people gave like two treats. Oh, well, that shot 2 treats out. So now he's extra spoiled. So no more bits or treats for you, Hubs. You are done. Little baby. He's a very good boy. Oh my gosh. Okay. All right. Sorry, Hubs. I gotta pull this back before I see the puppy dog face. And then I feel tempted to give him more treats. But there you go. There you go, Gamer85 and Definite Optimist. Thank you for giving Hubble treats. He's very grateful. I do have a treat dispenser device. Okay, so what was I talking about? Fully connected layers takes the input from the previous layer and outputs that matrix with a number of probabilities. Yes, okay. So that's the basics. So here's the thing. All right, we got like 7 minutes before, because I don't want to also take up too much of poor Tyler's time as he's here waiting for his turn to come on and talk to you about cool stuff. I had written down a bunch of notes on some other cool kinds of convolutional neural nets. So region-based convolutional neural nets, mask regional convolutional neural nets, because I just thought they were cool. But if we have time to talk about them with Tyler, we can, or we could just leave that for another stream where we maybe do a deep dive into convolutional neural nets. But Tyler, do you wanna call me friend? Let me actually get Discord up. All right, there's Discord, and then we can answer questions. Could I sum up the stuff in the last few minutes, please? Sure, don't drink and drive, bro. I'm not sure how much you missed, but we were talking about how with computer vision, some of the challenges, a lot of the challenges arise from the dimensionality of the image, and that our kind of traditional way of thinking about neural nets isn't really going to work. And so I introduced a new kind of neural net called a convolutional neural net that is far better equipped and designed to handle images. And so we talked a little bit about the structure of that and why it's different. But that's what we've been talking about for the last few minutes. And 69 Octavio, thank you for joining. All right, so Tyler is calling me, so let me mute. We're gonna actually mute the music for once. Where is the music? There it is. Okay. Bye, music. We don't want you anymore. Alrighty. So let's see here. Hi.
Hey.
Let me ensure that you are loud enough here. I'm going to crank my desktop audio up, crank my own audio up, and just give me 1 sec, friends, while I get a few things set up. I'm going to be just chatting, and then I will add your video. 1 second, friend.
No worries. 1 second.
Yeah, go for it. You still sound really quiet, so that might actually be on my end. Chat, how is his volume? And Third Tier Gaming, thank you for the raid. Oh, that sounds much better. Okay, I just cranked up my own volume, so there we go. And then let's see here. Okay, and then I'm gonna add your video. So hold, please. If you do have questions, though, Tyler can answer them while I'm setting up his video. But I will just be a brief second here as I find out how to. I have way too many things going on here. All right, schedule. Bye, schedule. We like you, schedule, but we don't want you anymore. Then we need a window capture. Capture. And then, okay, MH Zanerman has a question. How do convolutional neural nets use scaling and rotations and expanding affine transformations to the pictures that should be matched with a source image? What a question.
Oh,
there you go. We're starting you off. We're starting you off hefty.
We're gonna jump right into the deep end, huh? Okay, so there's a few ways that they address this. Typically, what I've seen in like practice and actually in my work is that you augment your training data such that your neural network ends up being invariant to these types of things. So you end up doing random scaling, random rotations, random flips, those types of things.
Yes. Okay. Oh yeah. I got the cropping working on the fly. All right. I'm just gonna cut this a little bit so it's more square. All right, go.
Yeah.
All right.
Maybe I should give some context to my background and what I do.
Go for it.
So my
I have a cool title for
my
you
master's
too.
degree is in computer science. I've done a lot of research in remote sensing and computer vision, so object detection and image classification, land cover, land use, object tracking, a little bit of that kind of stuff. And so you mentioned earlier in the stream that I am pursuing my PhD. It is in computer science. I'm going back to that same research lab where I'm doing object detection. I see your face as my audio.
No, I'm sorry. That was the Felipe Martins. Thank you so much for following. I had to turn down actually this will turn down the alert box for stream. I need to just turn down the alert box because lordy, that was loud. No, not you. Go talk about how amazing you are.
Obviously, we're friends, and you're very good to me. Yeah, so I've done a lot of work with the remote sensing space and a lot of image processing and computer vision. I've done a lot of traditional image processing before I dove into a lot of the machine learning and DCNN side of things. And so I've gotten a lot of really fun experience working with the challenges of working with imagery. So, and now I just recently rejoined Jess at our employer. And
Yes,
so I'm very
I don't
excited
mention
about
our
being back.
employer, so
Yeah, I didn't think we would.
just as a just as a it got super quiet. Oh no. Okay, hold on. That's probably me. God damn it.
That's funny, Savara. There's a lot of people that share similar last names to mine, but probably not is the answer. It's I can't actually be sure because we don't know the family tree that well.
All right, so I'm gonna have to mute the alert box for now. It should be better now. The sound should be better now. But I will just mute the alert box and notice when people follow and handle it, because I can't do I tried to turn it down, but it turned everything down. So, but yes, thank you so much for making the time. Also, it's good to see you. We haven't caught up since you came back, because life's been weird this week and this year.
Yeah, life's been very crazy, and I'm still currently in a hotel. Because we're closing on our house and everything. So we've both been very, very busy.
Tyler, can you just casually move to your right a little bit? Because I see some paws behind you.
Oh,
Can I see? Oh, Ollie. Ollie, by the way, is Hubble's almost twin. They look so similar. Oh my God, he's so cute. Ollie Bean. Oh, the tail wag.
Yeah, he sleeps most of the day. He's so cute.
Okay, so all of the energy that would be normally split between two dogs got to Hubble, and Ollie got like the snuggles and the like relaxing, and Hubble got all of the like sprinting and leaping and running and
Yeah, and if we're lucky, he'll do this really cute thing he sometimes does, and I'll like catch myself leaning back, and he'll like come over and just like put his paws on my shoulder, and then like insert himself into whatever I'm doing.
Oh my God. That is so cute. Okay, well, I saw the paws in the background.
Yeah, there is another dog. Riley, come here, buddy.
Riley.
He's got his toys right now, so I don't know if he'll come say hi. You come up? If I take this from you, Luke? No, you're gonna sit because you're a good boy. Here you go. He is. Sorry. I was trying to get him to come say hi, but he's content with his bone for the moment.
Oh no, that's fine. And Rat Sack, thank you for following. For some reason, that still blew out my eardrums. So, you keep telling people how amazing you are, and I'm gonna try to figure out how to turn off the sound, at least for me. Actually, alert box. No, that's just.
See if there was. I think I saw a question in chat. I'm looking for it. Okay, so Don't Drink and Drive Bro asked what function is used on the kernels. So if I'm understanding your question correctly, it's a good question, but so the kernel is used for the convolution operation, which if you have a traditional math background, it's not a convolution, it's cross correlation, or more simply an element-wise matrix multiplication, that is then summed also. And that's why it's basically a convolution operation which uses a kernel, but it's technically a cross correlation, and it's a big thing that I got hung up on a lot when I was first reading about all this, because I was trying to implement traditional image processing techniques using like a Laplacian filter or a Gaussian filter just on an image, just to blur the image or find the edges, which is actually just a straight up image processing technique. You don't actually need any machine learning to do that. And when you're reading about convolutions and then you're trying to implement it, there's a transpose that's missing that is very confusing if you're not familiar with what's actually happening. So the weights are being trained, and those are the values in the kernel, and the kernel is used for the convolution operation. I hope that answers that question.
There's often a small delay, so
there you are.
Yeah, okay. I'm here. I am trying so desperately to find the way to mute the notifications here. But so I'm sorry if I'm distracted for a second. But every time somebody follows, I'm gonna be like, dying a little bit. So,
I'm sorry.
um,
Is there something on my end? Do I just need to be louder so you can turn everything down?
no,
Because
no,
I'm
no,
really
you're
quiet.
totally
And that's
fine. No, you're fine. This is on me. Um, I had hoped that muting it, the alert box itself, in Streamlabs would help, but alas, it did not. Oh my god, he's so cute.
he
Not as
loves
good
no
as default
shrubs.
name. Oh my god, I can't wait. Like I need to meet your dogs. They're so cute.
Someday, in a
Someday,
post-COVID world, we're gonna fly you and love fun out, I think, and
yeah,
have a good time.
that would be awesome. I'm vaccinated, actually. Well, I'm half vaccinated, so woo. I'm
Yeah,
almost protected.
yeah, that's great. We are currently quarantined because we moved from LA County, and so, you know, it's like, yeah, we're gonna quarantine and then do all the responsible adult things.
Yeah. Um. Let's see. Did I invite him for you, Yurik? Your master's degree is remote sensing and ML. That's so cool. No, I invited him for me because my specialty is less computer vision. I've been doing a lot more remote sensing, but not computer vision lately. So it's been an adventure. I am glad that you're out of California, especially though with the with
Yeah, everything.
yeah, all of that.
The fires, the earthquake, the COVID, the everything.
Okay, it looks like there's like I would expect it to be such an easy fix, and I could have sworn I turned off notifications previously when we got that follow spam that happened, but
Oh yes, yes.
oh yeah, and there's some
Jess, I didn't
questions.
mean to.
Yeah, there's
Yeah.
questions.
So
Go.
so Severo, so thanks for bringing that up again. So the difference between object detection and tracking, and why object detection in every frame of a video is not technically object tracking. Um, Basically, there's a few different ways to do object tracking. The main difference is a semantic one, and it's one that we, like as humans, like there's a difference between saying here's something in an image, it's right there, and then being able to semantically track it and say this is that same thing, and here's how it's moving throughout an image or throughout a video, right? And so when we talk about in CV and we talk about the difference between tracking and detection, that's mainly the difference is knowing that not only where that thing is in each frame, but knowing that it's the same thing and being able to chart its path continuously rather than just at discrete moments in time.
Give me 1 sec here. I'm gonna test a fake follow. Oh, it's muted. Okay, I'm back in the land of the streaming. I'm sorry. Okay. And let's see here. Yeah. Whew. And then
Holsky, that stock trading programs, that is not something I want to do. That is very complicated and very challenging, and that I'll let the fintech experts stick to that field.
which is also not me. Railbird, you say, how would you go about creating an algorithm to recognize a live game of chess being played and then to generate game notation? So actually I feel like with a chessboard, that would really help because you have this grid that's kind of built into it. So you're not talking necessarily about getting a computer to play chess, but to watch a video of chess being played live and extract like piece and positions.
I guess it's a really interesting idea. It depends on how much information you actually want to distill from the imagery. So if you just want to, in each frame, say this this piece is positioned here and here's what type of piece it is, that's really just an object detection challenge. If you wanted to be able to also have the computer actually have a sense for what the positions on the board are, and not just that this texture exist in this image at this pixel location, but actually be able to generate the information of this type of piece is at this particular position on the chessboard and actually communicate that. That's a higher level of understanding and a more challenging problem.
So Don't Drink and Drive Bro says, and I should have mentioned this too, is that since I put the VODs on YouTube, I'm trying to make an effort to read out the questions so that people who are on YouTube and won't have access to the chat know what we're responding to. But Don't Drink and Drive Bro says, do you still need computer vision to identify the pieces, or could you just track them from the starting position?
So I would say you need computer vision to be able to track them, because you need their position and their velocity information typically, and how you derive that is through detection at various points in space over time.
And let's see. Yurik, you say, question, to identify and classify cultures like plants. Okay, so I think you more mean like species. The main strategy is to classify pixel by pixel, and are the main methods convolutional neural nets and random forest. So I'm thinking also, I've seen a lot of research done, applications of CV for agriculture in terms of like crop disease identification. So I imagine that species identification, presuming it's a species that is distinguishable through visual means, would definitely be a computer vision classification. I'm not sure why you would need the random forest on top of that. But there's like what I've seen, and Tyler can correct me, you're laughing, but a lot of times I've seen interesting architectures where the convolutional neural net actually spits out the final feature map, activation map, with like the activations for all of the complex features and everything. It's been passed through all these layers, and then that is then passed to a different kind of classification model. So I could see you doing that with a random forest. I'm not sure that random forest would be the way that I would go initially with that, but I don't see why you couldn't. And 99 Vandero, thank you for following. I don't know, Tyler, what do you think?
I mean, that's pretty much exactly what I was going to say. What you're describing of taking the n-1 layer and passing it off to a more traditional classification approach, or whether it's random forest or SVMs, or, this is all a lot of the cutting edge research is we have all of these ML techniques that work really well, and how can we combine them with basically, what we know about convolution and pooling. And so the pooling stuff's really important because it's not only reducing the number of features that you have to deal with, but it's also allowing you to gain higher level features and not get distracted by the noise in the signal. Because if you're looking at each and every pixel independently, there's so much information there, and there's so much data there that trying to discern something like curves or shapes ends up being really hard. And this is why in traditional image processing techniques, one of the first steps to a lot of processing pipelines is running a Gaussian over the image, is to try to reduce the amount of noise that's in the image. You also have, for me and the way I understand things, the max pooling layer, the way that it pulls out the maximum value in the space that it's looking at, the region that it's looking at. We do that a lot too when it's analogous to histogram equalization, which is another pre-processing technique in a lot of image processing pipelines. So it's all of these components of all these different things and how they tie together that allows us to build these really powerful systems.
Jan Poggy Man, thank you for following. And yeah, this brings me back to the stream I did on supervised anomaly detection, where it was like, I can show you all of these individual techniques, but like the strength often becomes when we smush stuff together. So like reinforcement learning is really cool, but guess what's really cooler is like, let's do reinforcement learning and have neural nets involved. So there's like, I feel like the cool part, like you start out with machine learning, and I feel like you learn these algorithms, these models in isolation. And it's almost treated like open and shut, that you will use model X for problem Y. And then when you get into like the real applications of ML, it's like, really, it's actually more about what feels almost like the classic inventor, right? Like taking all of these different parts, seeing how they fit together, but you have to understand what each part is doing so that you don't muddle entirely like the explainability along the way.
Yeah. Yeah, and so that brings up the reason why when you're asking about what features we might see in a
Yeah.
convolutional neural network, I said none reliably, because really when you're allowing so like for instance with traditional image processing we can use a Laplacian to find edges, um, and I really hope that that is the right kernel filter to use for that because I am going off the top of my head right now, um, but you can use it, let's say it's a Laplacian filter, in order to find the edges. um, you know that kernel filter has defined values that were discovered and like they are set. But with DCNNs, the kernel values are the weights, so that's what we're training, that's what we're changing. And so that kind of a consequence of that is you can't make any guarantees about what features are going to be utilized by your network, and especially because it's all tied together, it gets very complex. It's based on your loss function. It's based on your regularization that you use. It's based on the type of pooling that you use. Like all of this is happening to this information. And so you can't reliably say, oh, look, my network is definitely looking at this edge or these colors or this type of feature because you don't know that. And there's a lot of research, a lot of really good and exciting research into explainability of DCNNs. And so then what we ended up doing is kind of reverse engineering by playing with the bit value, the pixel values and changing them and watching where things start to break down. So then we can say, okay, well, when we flip these pixels to essentially random noise, then it was previously able to identify this as a dog, and when we added this noise in these locations, it's no longer able to identify it as a dog. So then we know, because of that, that these particular pixels are important to the network being able to identify this as a dog. Now you still can't even say, is it the color? Is it the shape? You still don't know for sure. You just know
Yeah.
that when we break these pixels, everything starts to break down.
And I think that's we've talked about this and my hatred for the term black box on this stream quite a bit, but there is like rather than treating neural nets as a black box, I feel like that approach of adding things, removing things, testing the differences so that we're able to get as much explainability as possible is really important because I've seen this approach and it is something that makes me want to, bang my head against a wall, which is I read on the internet that this particular architecture works for this kind of problem. So I'm going to shove my data into it and call it a black box, and there you go. And that kind of machine learning deeply upsets me. But in any case, Severo asks, if I want a bot to accurately shoot grapes into my mouth by using facial recognition, is it reasonable to make it identify and designate features of a face, as in a mouth versus the eye, or would it be easier to just identify the bounds of a face and break that into subregions where human mouths and eyes typically are? I want to say like ¿por qué no los dos? Like, why not combine the regional approach of breaking down the face with the like classification of features as well? But I don't know. You're the expert. You tell me.
I really love this question because it really picks out a lot of the ways we used to do things and still do things. There's a technique that was called visual bag of words, which
so all of you who were here for the NLP stream, you know what bag of words is. So
yeah, probably better than I do if I'm being honest. Because this was explained to me as a history lesson by my advisor, and I never actually touched it directly because that's not how we do things. But the way he explained it to me was that essentially you have these different visual components, and that if all these things appear together, then hey, this is a face. So like if you find a nose, eyes, ears, and a mouth, that's a face. The way that face detection is typically done nowadays is with a DCNN where we're not hand controlling which pieces of the image or data that the network is learning. We simply draw a bounding box or give a pixel mask of the area that is the face, and we say, hey, find the face in this image. and it starts out really horrible, and it basically randomly guesses, and we tell it, nope, that's not the face, and then we do this millions of times, and eventually it says, hey, I can find the face. If you specifically wanted to shoot grapes into your mouth, that means
Which
you need to
also
be able
excellent
to,
example.
yeah, you need to be able to specifically identify where your mouth is, and hopefully whether your mouth is open or not. Um, and if I were to trust my face with grapes being hurled at it, I would ideally wait until the mouth was sufficiently open, in order to launch those. So there's a lot of really cool ideas there in that question. I really love that question. But yeah, so typically you kind of got it in the second half there where you identify the bounds of the face, but you don't even break it into subregions, really, mostly. You kind of just let the neural network learn what your face is. Now, if you were to, again, if you were specifically looking for the mouth, then actually you wouldn't necessarily need the whole face. You would just need the mouth portion, but you could definitely take there's multi-layer approaches in model ensembling that could say, okay, I'm going to find a face, and then within a face, I'm going to take that output as input to another model that is trained just to find the mouth inside of the face, which can get you a lot more accurate results, but you're adding more processing here. So then it depends on how much hardware you have, how much flexibility you have, and also how real time you need the results to be. And that's I'll try to stay brief. I could go on tangents because all this stuff is I love this
See, it's
stuff.
hard. It's hard talking about like things you love. That's been the challenge of the ML streams. That's why like the ones where I was like, oh, linear regression. I have taught this so many times. It was like 2 hours, and then I get to reinforcement learning, and suddenly the stream's like 5 hours because I was like, I can't shut up about this stuff. It is so freaking cool. So I feel you.
Yeah.
It's I think to hammer home a theme for the 12 days of machine learning myths that I think we've come back to again and again. Machine learning often is about those decisions and those trade-offs. And so I think, I've gotten a lot of questions about how do I get started? How do I do this? How do I do that? And that's how kind of that you've moved past being a beginner, I feel like, is the beginning step is to get familiar with a lot of these different models and, kind of understand the math, the pros and the cons maybe. And then you hit this point where whatever level it is, where you're more accustomed to having to sit there and go, what are the trade-offs for this situation? And how do I balance these different trade-offs? And how do I, optimize things for whatever use case this is, the data type, like, do I need this thing to run in real time? Or do I have like, it's fine that it takes forever to train, but then I won't be able to retrain it very frequently. Like all of the kind of the operationalization needs, and then making those decisions to fit each use case. So it's so hard when people come in chat and they're like, what model would I use for X? And I'm like, depends. Anyone who sits there and tells you categorically always you can use model X for purpose Y, no, like,
Yeah.
it doesn't work like that. And this is why people hire people, hopefully, like me and Tyler, because these are the questions that are difficult to answer, but we get these problems of like, okay, not just can you make a machine learning algorithm to shoot grapes in my face, but can you put it on an iPhone and make it so that, it'll recognize any face and do this, and also work with, I don't know, children and adults and old people and also my dog, but also I don't want to rerun it that often, and it's okay if sometimes it hits me in the face, but it always needs to shoot the grape when my mouth is open. And you extract that into like, precision and recall and like what compute you have and all kinds of things. And those trade-offs make up the decisions. Yeah. There was a cool question. Oh no, you go, and then I'll read more questions from chat for you.
I saw recently from Goofy Lagrangian, given the infinite amount of funding for your PhD, what problem in computer vision would you like to solve and work on? I am extremely fortunate that my PhD is funded. And so I will have not infinite time, but I will, get to work on things that I want to work on. And I haven't yet. We're just starting literally at the beginning of the month is when I started up again. So we'll see what I end up actually working on. But I really like working on the things that I do work on with remote sensing and object detection. and these types of things because for all the reasons that we were just talking about with explainability and how important it is. And there's a lot of really powerful things you can do with these technologies, but understanding how they work and doing things that are generally positive for society, that's the type of stuff I want to be working on. And so, you know, I I'll stay away from specifics, but generally, I work on things that I feel good about and that I sleep well at night doing. So
That's a good. I I make that a mandatory part of my employment. But
yeah, of
Nightcrawler,
course.
thank you for following. And let's see, ATX Pete, you mentioned earlier that it's difficult for machine learning to classify galaxies. Is it possible and is it happening that we are using machine vision to detect asteroids and comets? It seems the discoveries I see mentioned are still done the old-fashioned way. Well, this is something that might be hard to believe, and there's like a younger generation of astronomers and astrophysicists that are definitely going in a new direction. But the traditional ways of observing things and identifying things still holds great sway in astronomy. I feel like my hunch would be, and actually I have a friend who does remote sensing machine learning and used to do stuff. She's a planetary astrophysicist, and also she now works where I and Tyler work because I got her hired. And I'm just stealing all the cool people.
Oh,
Yeah,
me
you
too.
guys, she's really cool. And she's done stuff, I believe, or she knows more because she's a planetary astronomer. She's going to know a lot more about near-Earth object detection. I would imagine that it's going to be easier than classifying galaxies because really you're looking for it, like the resolution that we have at the distances that we would like to be detecting these objects is like you're looking for a cluster of white pixels in a sea of black that is moving. So that's going to be a little bit easier than, oh, here's this like incredibly complex diffuse object that we have put human classification on that doesn't always fit our human classifications, but try anyway. So I feel like it would be easier, but I want to now grab my friend and see if she'll come on stream and talk to us about machine learning for astrophysics. But let's see here. There's probably a bunch more questions. And yes, Kriegersaurus Rex, he says that it is great that you have the freedom to pursue the topics you want.
I'm very, very lucky.
Yes, I'm jealous. And then let's see. Oh, Goofy Lagrangian with another great question. What was the big aha moment that got you into machine learning and computer vision?
If we're being like real honest, I took a high performance computing class with my advisor, and he's a really awesome guy who is really good about inspiring people to work on really hard problems and helping them see how exciting really hard problems can be when you solve them. And he does research in remote sensing and computer vision, and I wanted a different job than being a TA because that's what I was doing at the time. And so I said, "Hey, do you have any research positions open in your lab?" And he said yes, and so I started working for him. And then when I was finishing my undergraduate degree, I did not have a job, and so I said, "Hey, will you keep me around for a little bit longer, and we'll do this master's degree thing?" And I was very lucky, and he kept me around, and so that's how I found myself in remote sensing and CV. And yeah, the rest is kind of history from there.
um, and Whatchamacallit27 says, is there a specific hardware that excels at computer vision? GPUs, FPGAs, quantum?
I am not qualified to speak to quantum and how
Me
good or
either.
not it is. Yeah, I know we know some people who are very brilliant and do quantum, and I would be happy for them to answer that, but I won't even touch it. I know GPUs are really good at it. FPGAs are even better when done correctly. It's really hard to do though. Writing FPGA code is not an easy task. It's one of the more difficult things I've ever seen done. I haven't gotten a chance to do it myself. I've just read about it and looked at some of the implementations and said, "Yep, that's real." Um, so, it because it requires you basically so FPGA is a field programmable gate array, and so you're basically on the fly redesigning the hardware to meet your software implementation, you also have to change your software implementation to meet your hardware. And so it's this happy dance of trying to find a middle ground between your normal GPU implementation and excuse me, and actually what you're capable of with the FPGA. So if it works, FPGAs are super fast and a lot more affordable than the same compute power based on GPUs. And that's why a lot of places are going to using FPGAs for their acceleration.
And Andika Razari, thank you for following. And so also, this is like totally a random aside, but if you ever want to collaborate on a Galaxy identification CV model and see if we can crack the challenge, hit me up because that would be fun.
Yeah.
Also, because I don't get an opportunity to do enough ethical CV or like CV that's not making me feel icky inside. So I would love to have a chance to learn more without having it have that sort of weird connotation. And Lofoot says, "Oh, you've enjoyed your FPGA, Mister. Well, who is the wonderful human who got you that for Christmas?" And let's see. Yuriki say, seems that... No, what?
I was just gonna say, I see Third Tier Gaming saying he wanted me to answer, but I don't see what he wanted me to answer.
Oh, it was a slightly off-topic question, but he says, you have the ability to revive any TV series for as many seasons as you desire, but in exchange, one of your other favorite shows will cease to exist, and only you will have memory of it. What show do you revive, and what show do you destroy?
Oh. Trying to think of one that I like that was canceled, because I don't actually watch a whole lot of TV, to be honest. I know that... See, Lucifer's really good, but I don't think it's technically canceled. I think it's still ongoing. It's just slow. So, yeah, I'm gonna have to pass.
Yeah, it's tough. Don't drink and drive, bro. You say, what's your favorite textbook ever? For better or worse, mostly because of happy memories. Mine would be Griffith's Quantum Mechanics. That book made me fall in love with everything quantum, and makes me, I mean, like now it's like I've said in Discord to people giving me quantum computing resources, it makes me want to look into that even more. But that was an amazing textbook. And really quick, Max2320, thank you for following. But what's your favorite textbook, Tyler?
I have so many that I love so much. And I'm looking around as if I have my books out, and again, I'm in a hotel, so I don't.
Yeah, I know.
So,
I think I put mine away.
so it depends on where you're at in your journey and what kind of information you're looking for. I really, really liked a book called Algorithms Unlocked by his last name is Corman, and it's the same Corman of the what's the name of that book? It's the MIT algorithms book that almost everyone who took CS in college will know. It's that other book is like 700 pages. I'm not kidding, like that thick. It's gigantic.
I'm self-taught. I don't know.
It's a big one. Why can't I think of... Yeah, I can't think of what the name of that book is. But Algorithms Unlocked is basically a shortened, condensed, and approachable version of that book. And so it's a really good read that's really fun. It really... I just love how approachable it is. It walks you through proving that no comparison-based sorting algorithm can be faster than n-log-n. And then it's like, but we said comparison based. So here's a few sorting algorithms that aren't comparison based. And it's like, oh, I didn't even know you could do that. And it's like, of course you can, but like, I don't know. I just really loved reading through that one. I have a lot, and it would be a lot easier to answer that kind of a question with my bookshelf behind me, which is usually the case.
We'll let you you can revisit your conclusions if you need to when you have your books in front of you. Because also there's like this... Oh, no, go.
Sorry, I was just going to say, Don't Drink and Drive, Bo. It's Introduction to Algorithms by Corman et al. That's the name of the book.
I feel like it's a challenge too, if you're in a field Well, if you're in a field that you love, because definitely there are those textbooks that you, when you first were starting out, that have that like nostalgic feel for, like, at least for me, like the Griffiths quantum mechanics was just that like nostalgia of being in grad school and just finding quantum mechanics like the coolest thing ever. But then it's like, also in machine learning, like our field is adapting so quickly. New textbooks are coming out all the time. So usually my favorite textbook is the one that I'm reading right now because I find it super cool. So it's just like, like I tried to cut myself off from like the ones I'm going through now. But if you ask me like 6 months from now, it's probably going to be whatever cool textbook I've acquired then. And it's like, oh my God, this is life changing. Like, this is so cool.
Yeah.
But
I totally get that too. My favorite paper is always the one in front of me.
yeah, yeah, exactly.
It's usually because if I don't like it, it's only in front of me for a few seconds.
I've been there. I wonder though. This is a challenge I've found, at least. Sometimes in mentoring people, or sometimes kind of stepping in to kind of fix projects gone awry. But that, while I think, you know, you and I have done this for long enough that we've tempered sort of the this desire, but if left unchecked, I feel like that just, oh, the paper in front of me is the coolest one ever, leads to kind of the model I've just read about must be the best ever, and therefore I'm going to try to build it everywhere. And this is something I keep running into. And Demilux, thank you for following. This is something I keep running into in both like my work and my non-work, where I step in, I'm like, why did you pick this model? Well, oh, this paper was just published like 5 months ago. It's so cool. I really wanted to build it. And I'm like, is this actually the best like key for the lock? Like, is it actually the best approach? Or did you just go, oh my God, it's cool? Because I've been there. I've looked at really cool papers, but like, oh, I want a chance to build this. But like, it's some weird kind of machine learning brain of like, everything looks like a nail when you have a hammer that's your new machine learning model. I don't know. Like, it's a weird thing I keep seeing everywhere.
Yeah. No, I mean, you perfectly described one of the challenges of working in our industry, in our field. You'll see that a lot, especially with pre-trained out-of-the-box models. Somebody will say, "Oh, this worked super well for, you know, one of these classes that was in the original training data set. So now let's, you know,
now it's got to work great for everything."
Right. Yeah. So let's just take that and just apply it in a remote sensing context. Let's just completely ignore all of the challenges of remote sensing and just, yep, it was trained on ImageNet. And what's so frustrating.
Okay. I'm good. I'm controlling myself. It's good. Go.
So what's like maddening about that, right, is it works to a point. Like it shouldn't, but it does to a point. And so it's like, well, look, you know, we got X% performance, and it's like, well, okay, but that, I don't know, it cheating's not the right word, but it's just like there requires more finesse, more nuance, more understanding of the problem domain, especially because depending on what you're actually trying to do, maybe you're okay with your accuracy being kind of shitty if if it's very important to you that your recall is very high. And the classical example of this is if you're trying to detect cancer, you would much rather have a false positive than a false negative.
Those of you who did the classification YouTube video, or you can go to YouTube. Classification video is where we talk about, you know, recall, precision, the trade-off, cases why you might want to maximize either. So if, as an aside, if these are topics that interest you, as a shameless self-plug on my own stream, I did a video on that. So, but...
I have this... Sorry.
No, what?
I have dyslexia. His name is Don't Drink and Drive Bro, not Don't Drink and Drive Bro. And I just now realized.
It's an excellent name. It's one of my favorite
It really is.
One of my favorite usernames that's come into chat. But let's see here. It's let's see. Okay, YouTube. Oh yeah, Confusion Matrix. Yeah, the name has a reason. I like confusion matrices. I don't know. Like it's just such a quick way to be like, instead of just looking at your accuracy, I'd much rather see like label-based performance. But
It's hard to look at when there's 60 plus classes.
Well, yes. Okay. All right, Mr. CV. Yes, exactly. All right. I'm thinking about like normal people use cases, but fine. You off in like weird CV land with your like, here's every single kind of animal, dog, like chair, whatever. But see, this is like, this is the thing. Like, no, even what?
Oh, I was just saying, well, a confusion matrix doesn't actually make sense in a detection application because you don't have a discrete, like it makes perfect sense for classification.
Yeah.
For detection, your negative is, I don't want to say it's infinite because then we get into like real strict math terms, but like your amount of not the thing positions is so high, it's really hard to conceptualize a confusion matrix for like a detection scenario.
And I mean, if I'm thinking about like detection in other machine learning context, it wouldn't make sense to have a confusion matrix there either. So that makes sense. And Yuri, I'm sorry, yes, you asked this question earlier and I missed it. It seems that Kaggle doesn't have much in terms of projects on remote sensing. Are there other sites to study it deeper with notes and algorithms?
So,
putting you on the spot here.
Oh no, I'm ready to answer. I was gonna give you a chance to answer.
No,
I didn't
please
want to
go.
feel like I was stepping on you. So for it depends on what kind of remote sensing you want to do. One resource that I recently referred to and was really good is if you start looking into things like synthetic aperture radar, which is not your normal type of imagery. It's going to look very different and it's made very different.
Cool.
It's not. It's very cool. It's also one of the most challenging things I've ever worked on.
It's also really expensive, isn't it? Or am I thinking of something? I feel like it's really expensive.
It can be,
Okay.
depending on what data you're trying to get and where you're trying to get from. Exciting news, fairly recently, a new commercial satellite became publicly available, and you can buy their imagery from there, and I think it's called Capella. But you can access, you can buy that data. That is a big announcement recently, so that's very, or that might, but all these satellite names are like names that I'm horrible with names. I might be making things up, but there's a new commercial SAR satellite that you can access the data. But anyways, I was going to say NASA has a lot of really great resources that are freely available online for learning about SAR and SAR processing and in a remote sensing context and how you can do all these sorts of image processing things without even getting into the ML necessarily. So
really quick, Accessible Gamer, thank you so much for the raid, and welcome raiders. Welcome to our computer vision party. We had a brief segment earlier in the stream where we talked about the basics of computer vision, and I went through kind of what a convolutional neural net is, how it differs from the neural nets that we've used before in the 12 Days of Machine Learning Miss. But since this is our last day of the 12 Days of Machine Learning Miss, which I forced that, I made that work, and it didn't fit. I'm having my colleague, Tyler Nivin, over there, who is a machine learning engineer that has focused, is especially, I will say expert, you won't use that word, but I will use that word, in computer vision. And he is here to answer all computer vision questions and bestow upon us his computer vision wisdom. Because I've done maybe I've done a lot more remote sensing, but I've done like a handful of computer vision things, and it's not my specialty. But welcome all of you also. For accessibility, there are closed captions, by the way, that I've gotten good feedback work excellently. Please let me know if they work. The thing I haven't tested is if they work if I have a guest. So if they don't, let me know, and I need to figure out how to make that work. And more accessible version of my stream description coming soon. So I was also told that like the images are not very accessible, so I'm going to turn those into text and added some other stuff to make it even better. So because Accessible Gamer is from the Accessible Gamers community and stream team, and it's all about accessibility in games, and for me, I add on to that accessibility in games and science and tech. So it's great to have all of you here. So there's a question from Don't Drink and Drive Bro saying, does Tyler have a favorite theorem, by the way? This is just like what are Tyler's faves? Like your favorite textbook, your favorite model, your favorite theorem. Let's go.
I am not nearly enough of a math nerd to have a favorite theorem, and I say that with the most love and respect for math nerds. I actually really
You're
like.
hurting me.
I struggled with math in school. Like, as ironic as that is, that was by far the thing I struggled with most. And so, like, I don't even know if I could name like five theorems. Like, it's embarrassing. It's just not the part of the it's not the part of the things that I actually really enjoy and spend a lot of time focusing on. I have had to learn a ton of advanced math in order to do what I do. But it's I mean, there's a lot of really cool factoids, but I'm not, I don't know. I've never memorized any particular theorems or
Time
names or
dependent Schrodinger equation, obviously. Just saying.
see, that's why I tell you you're so much smarter than me all
I'm
the time.
not. I'm not. I'm really not. I just
So
like
much
math.
smarter
Just
than I
like it. Just like it's like that feeling when you eat something that tastes like really delicious and it just is comforting and it's wonderful. That's math for me. It's a security blanket. I like it because when the rest of the like world doesn't make sense, like give me some nasty looking like theorem, and then I'm just like, oh, I'm gonna figure this out, and it's gonna feel so good to figure it out. So.
Yeah, no, the letters aren't my friends when it comes to math.
Well.
I joke about that because I struggle with being able to read the equations, which is a totally separate topic. But
No, that's extremely common. And so one of the things I actually use when I teach math is like I'll turn it into letters a lot of times last, but I'll actually like write out equations with the English because I feel like it's important not only to do that for your variables and things like that, but if you have an equation that's made up of a bunch of like subcomponents that are doing things on their own, like label them, figure out what they do, and then suddenly it doesn't seem like this like giant page of gibberish. It's like, oh, I'm just doing like, oh, this makes sense. This is just like the average of this, or this is like comparing these two things. And when you kind of do it like that, I don't know. I find that it makes it a little more easy to understand sometimes. But
yeah, I also had a really like myriading and not linear math education, and so like I never was formally taught all of the Greek math symbols, so I have to pick them up as I go, and it's
mm-hmm.
happened so frequently that whatever class I was in or whatever equation I was reading, it's assumed that I know what that means. And it's like, I don't know what
I
that
hate
means. And I
that.
don't know
I
how to
hate that.
Google
Yeah.
it. And it's like, I don't know. I've gotten better at it in the last 7 or 8 years, but it was a big struggle at first.
Oh,
I
I
did
will
see,
share this embarrassing moment, which is I remember I was reading a some kind of like Bayesian processes paper for machine learning, and I literally had to Google. I was like, "What is the giant pi?" Like literally, why is there a giant pie on this page? What the actual hell is the giant pie doing?
yeah,
So I had to Google what is the big pie symbol, and like I read up on it. I was like, "Oh, okay," but like we've all had those moments, so.
I literally had that moment. We worked with a PhD in statistics, and we were in the office at the time because it was quite a while ago. And I walked over to him and I said, "What the hell is this? And what does it mean? And I don't understand. And can you please help me?"
Yeah, that was me when I got that paper. I was like, oh boy. And then I realized that that was for me it caused a good tangent, which is what led to me realizing that there were gaps in my statistics knowledge needed for machine learning. So I went off and I got myself a statistics textbook and I read it, and I was like, okay. I felt so much more confident after that, but it was like it was nice to actually confront that and be like, oh, I need to. Are they cuddling? No.
They are both on the bed, yeah. Let me see. Let me see what you can see.
Little.
Yes. So Riley's the black dog there, and Ollie's there. He's licking his paws. Hey,
Ollie.
hey bud. Don't lick your paws on our bed, please.
He
Wanna
looks at
come
you
say
like,
hi?
oh, what a
You wanna
good
come say
bandana. What a good bandana, Ollie.
Yeah.
Oh my
He's
god.
got a Christmas bandana. It's got snowmen on it.
Ollie. Oh my my god, he's so cute. He also reminds me so much of Hubble. Like,
Yeah,
I think it's like
that's
his oh my god, they are so cute. How do you get anything
there's so
done?
it's a challenge. I did see a question earlier in chat from ATXP. He said, I was wondering if you had the ability to put a satellite in orbit, what application would you apply ML to? I asked because we are about to launch our first rocket and are starting to think about applications for small sats. And so that literally is up my alley and what I do a lot of. So there's a ton of applications for ML on remote sensing based imagery that is facing the Earth, which is as opposed to facing out into space, which is a lot what Jess has worked with. So for aerial imagery and like for satellite type of imagery, there's a lot of things that can be done depending on the resolution of the satellite and depending on um, the modality of the imagery that you're using. Like I mentioned, SAR is super fun and has a lot of really cool stuff, but it has some challenges. So for specific things, there's a lot of like land use, land cover that's done. Just mentioned identifying crop diseases. I've seen things that like academic papers that talk about identifying the health of crops in general, like the yield, predicted yield amounts, and also like whether or not they're getting enough water, whether or not there's been like devastation. A lot of really cool humanitarian efforts around detecting natural disasters, which I don't know if you've told anyone, but if I remember correctly, you worked on a little bit of that at one point in time.
I did.
So that's really cool. You can do things like that. Tracking the extent of the natural disaster and the population also, and like where masses of people are and where they're going and what they're doing and that sort of thing. Not at like the individual level, but just like as a, you can see 10,000 people on the Earth from space pretty trivially. Or I'm just throwing 10,000 out there, just a sufficiently large number of people as a crowd you can see. And there's been a lot of academic studies around that too. So there's lots and lots of cool applications.
And don't drink and drive, bro. Yeah, I was sassing. Sorry. I thought that was why you were putting sin x equals x. Because that is an approximation used to also calculate the distance of stars from parallax. So it's a, whenever I teach some basic trig, and people are like, oh god, sine, what the hell, like this doesn't even look like anything, I love to show parallax because I'm like, no, see, look at this is a beautiful relationship that we can exploit to figure out how far stars are away from us when we can't measure the distance. Like, this is super cool. So that's I'm sorry, that's why I got overly excited about that. But
there's a couple questions around Big Pi, and I'm probably going to explain it horribly, but the conceptualization is summation but with products instead.
Yes. So there's like you all have seen me like write the sigma, right, for and that's often called summation notation. So how do we sum things up? The giant pi is product notation, so kind of like summing but with products. So you actually said it perfectly, because that's also my understanding of it too. Just get a tape measure and send probe like y sine. Oh, hilarious. Go look up the light years to the nearest star and come back to me. Don't drink and drive, bro. And men F1 and thank you for following. I'm so bad with the names, but in any case, so actually one question I would love to ask you is, like, is there, and we can't talk about work, but like, even if it's just conceptually or like abstractly, is there just like a project or a task or something that you saw machine learning or computer vision specifically applied to that just like blew your mind, where you felt just like, this is so cool? Because I would love to know about the, like, I mean, I've read so many things on all the classic examples of here's what you can use computer vision to do, but I'd love to like hear kind of the unexpected things, or the things that like you as somebody that does this thought were really, really cool. Oh no, did I
I'm
open a
trying
can
to
of
think of
worms?
an answer that I can tell you. Because
Or
it's
something I've
been
done is like change. I've talked about the approach, but I've changed the topics before as a way to like sidestep things if you're able to.
it's one of those things that we can't even sidestep.
No
It's
worries. I got a few of those
if
too. So,
yeah, so
yeah, no
but
worries.
so like when I have an academic paper on this, so I'm fine to talk about it. One of the things that we did while I was in my graduate degree was identifying Chinese surface-to-air missile sites using remote sensing imagery.
Okay.
So that was huge because we basically downloaded all of the country of China and processed all of it through machine learning models we had built and found two new SAM sites that were not previously known to us, at least. I won't say that they weren't known at all because I don't know, I don't have that information, but they weren't in the set of publicly known um, sites that we had at that time. So, and that paper is actually published. It's in the Journal of Applied Remote Sensing, I'm pretty sure. Yeah, JARS. Yeah. And then Markham, Richard Markham was somebody who I worked with at the time. He's first author on that paper, and then our shared mentors, Dr. Davis and Dr. Scott. That was probably the coolest thing I
What
did
made it
during my
cool to
graduate
you?
degree.
Like not cool. I mean, like to
I
you
had no
though.
idea
Like
that I had no idea that that was possible, and it kind of blew my mind because it's one thing to be like, oh, we're working with this public data and we're working with this, and this is all public data too, but we're working with these public data sets and, here's the training data and here's the validation data and we're going to play with the network architecture and try to get better performance out of it. Or I gave a conference talk on class-specific augmentation and how much or if at all that can help when you're trying to
you want to
train these.
explain that for our
Sure.
lovely friends in chat?
Sure. So data augmentation is a way to say, okay, I don't have enough data, so I need more of it. So you randomly flip the images, you randomly rotate the images, and I kind of alluded to this earlier. It's a way to deal with and scale and variation and rotation and variation. Um, so if you don't have enough to
So
train a model, you can do a lot of sorry, I'm struggling to talk. It's
no, I
at the
was
end of a
laughing
long
because
day.
I literally was like, oh my god, we need to have some offline conversations too because I have some horror stories that normally we would be telling each other over beer. But
I see.
I got yeah I've got some things that'll make you. I want you to
Sure.
die inside a little bit because I did. Share my
Okay, yeah,
pain.
we'll catch
That's
up soon.
friendship.
Off off lane. Yeah, exactly.
Yeah, off. Exactly.
But so then so that's in general data augmentation. For class specific augmentation, the idea of what I was looking at was we have an imbalanced data set. We have lots of examples of some types of features, and we have very few examples of other types of features. So how can we balance out this representation of the different and when I say features, what I mean in this context is different types of things. So I was looking at
Mm.
at the time I was looking at different like pieces, different nodal road network features. And so what I meant by that is like things like intersections, T intersections versus Y intersections versus highway on ramps and off ramps versus roundabouts, and so all these different like types of nodal road network features, like nodes in the road network. Um, and so, we had all this data for all these different types of features, but it was very imbalanced. So can we augment, instead of augmenting randomly across all of our data, can we augment just some of the classes in order to balance out that data? Because if your data is too imbalanced, then your network will actually it will learn the classes that it has more samples for much better than it will learn the classes that it has fewer samples for. And this can cause it to perform well on one class and perform horribly on another class, which that behavior profile can be hidden from you when you're only looking at something like an F1 score that's averaged across all your classes, or a MAP score that's averaged across all of your classes. Like, you can't see that kind of behavior, that performance disparity, when you look at a single number for an overall performance of the model, which is actually why I really don't like when we start trying to say, oh, this model has 95% accuracy, especially when it's a multi-class classification or detection model,
Yeah.
because it's like, it doesn't even make sense. Like, you literally could be perfect at one thing and 1% at the other thing, and you're just saying, oh yeah,
Yeah.
it averages out to, I guess in that case, 50%. But it's like, what if somebody using that model, you're saying the model has 95% accuracy, they're looking for that one thing it's bad at, and then they're going to be like, well, they're
Yeah.
claiming it's so great, but I'm looking at it and using it, and it's really bad. That's why I really, and
Metrics
all
are
of them,
important.
yeah,
If that
yeah,
isn't
and they're,
like, so there have
yeah,
been so many things I feel like I've tried to drill into people's heads, like, you know, EDA and cleaning and pre-processing your data is critical, and it's my TOL alarm.
oh
Later.
goodness, that's
You're back to that.
mine's about to go off.
Oh yeah, yep, we know that life. But also that, like, metrics are really important. Understanding your metrics, using the proper metrics, because especially if you are in a position as a machine learning developer or engineer where you have to communicate results to non-technical people. If you just tell a random person on the street, oh, this is 95% accuracy, and you give them no other information, your average non-technical person is going to be like, yeah, awesome, that sounds great. So, like, you also have a burden or a responsibility to use the appropriate metrics and to communicate them effectively to people who don't understand, the things that you're talking about. Because the improper metrics, the just, like, literally what you just described happened today. So that was great.
I want to take a quick second just to address something because it's important. Yeah. Absolutely nothing we are talking about is classified at any level. We would not be talking about it if it was.
Did someone say something?
I think they were just making a joke, but I just want to be 100%
Don't joke,
clear.
please. Like, can we not make jokes about that? Like,
yeah.
That could affect our jobs. So please don't make jokes about that. Like, Tyler was just talking about a project he did, like, I think in university. So, like, even like,
and that's why I said it's a published paper that is in JARS. And
yes. So we can, but like making jokes like that or kind of casting that doubt can cause a lot of issues. So please don't. Those I know you thought it probably was like well intentioned and you just thought you were being sassy, and that's fine. But let's not make jokes about that. Hi Remy 1134, welcome. But so it's funny because even as you were talking, I was thinking about because you were talking about map scores and everything, and I think one of the challenges in at least teaching machine learning or communicating it to people who don't have a background in it is all of the terminology and the acronyms. And so one of the things that is really funny is every time I hear map score, like I think of mean arterial pressure, which is it's a measurement of the mean, obviously, pressure in your arteries throughout your body, and there's like a minimum amount of it needed to sustain organ perfusion, and that is something that we consider in a pre-hospital emergency medicine. But it's just like it shows. I mean, I knew what you were talking about, but that's where my brain went first, and so it also shows that like the danger of terminology sometimes is when you're talking to a big room of people and not everybody has the same background as you. And especially with machine learning, where we love our acronyms for our different models and like all of our different technical terms that might be and are often used in other disciplines and mean different things. So it was a funny reminder also as we were talking about the importance of choosing effective metrics. Also the difficulty in terminology as well, and like translating things into everyday speak. But Remy asks
Yes.
what we're all doing. Welcome, Remy. This is day 12 of the 12 days of machine learning, miss, as you can see above me. Our last day. This was our schedule. If you're interested in any of these topics, you can see the videos on YouTube. You can see the code and some basic notes on GitHub. And today we were talking about computer vision, but I brought in my colleague, as you can see, to also talk to us. So we're answering questions about machine learning in general, data science. His specialty is computer vision, and that was our theme for today. So there's been lots of questions, obviously, about that. But also, like, feel free, those of you who are starting out or interested in the topic, to ask questions more broadly as well if you would like. But Don't Drink and Drive Bro asks, since you were dealing with missile launch sites, did you tell anyone about it before you published? That's a very interesting question, because I stay far away from topics like that myself in my work. So, like, I've never had to wonder with a conclusion like, oh, should I report this to someone? Should I tell? Like, so.
I let my advisors and the Center for Geospatial Intelligence director, who's one of the authors on that paper, Dr. Davis, they handle all communication pre-publishing. I just typically don't talk about any of my work until somebody else puts it out there.
Yep.
So yeah, the goofy Lagrangian said that as a grad student, that's way above my pay grade, and that's exactly what it is.
Yeah. So let me think. So those of you who are new to chat and just stopping by, that's what we're talking about. But also, this is the closeout of 12 days of machine learning. Man, this has been a marathon. Like, it's been a fun marathon, but it's been a marathon. So Tyler also is very knowledgeable about a lot of these other topics as well. So if you have questions for either of us, a lot of the things that I did teach you and I shared with you were kind of the basics, like the foundational things that a lot of data scientists or machine learning developers will know. So there's lots to chat about. And you say that sounds like fraud detection stuff? Wait, which thing sounds like fraud detection stuff? Don't drink and drive, bro. But yeah, so it's been a good series. Thank you, by the way, also for making the time, because I know we have a time difference, and this is your first week, not only back after the holidays, but back being co-employed with me. So yeah, it's probably been a tiring week. So thank you. I kind of hit you with this randomly, but
no, you're totally good. It's been a joy, and I sound like I'm saying that. I'm not necessarily. But it's been a lot of fun. I'm really glad to be involved. We've talked about doing something together on stream a lot, and this is the first time we've actually done it. So
stream. Look at this. This is something we've been talking about. So
yeah, it's actually really good to get the chance to get together, and I thank you for inviting me.
Yeah.
I'm always
computer
happy to
vision.
talk about this stuff.
You are my computer vision wizard. So I was like, crap. And also today it was just like one of those days where you sit through like a lot of meetings and things are just not going your way. So I was like, I was so grateful that you're here, because I was just like, I'm going to get through my section, and then it's going to be so much more fun to sit here with you and talk about machine learning and all kinds of things like that. But no, the spoilers are really just that Tyler and I have talked about co-streaming some educational data science content, or doing some just like live development of machine learning stuff. So you all have shown me over the last 12 streams that you have a deep and undying craving for more machine learning. So as we move through that, Tyler's gonna get brought into the fold of Please Help. And hi Hannibal, welcome.
Happy to be here.
Yeah, it's been really fun, and we've talked about a bunch of different topics. It's interesting because I think, Strophium, hi! So Strophium is one of my friends who is also volunteering his time so wonderfully and generously to teach me game development. So I've been making the games of Strophium have been cute and nice. On my own time, I've been making really shitty video games in Unity, and it's been an absolute blast. Also because, have you done any C#?
Have
before?
I? I not really know. My roommate loves it, or roommate. My roommate from college loves it. But no, I really haven't dabbled with it much.
It's really cool. It's really cool. Like I don't know. I learning it has been really fun. It's on my list of those things I want to code more in, like Julia, where I just was like, this is awesome.
Yeah.
You okay? You have feelings. You have feelings about this. You're just like, I see the sass on your face, Tyler. I know you. Why do you feel sassy about C sharp? You can have unpopular opinions. It's okay. You don't have to be happy all the time. You just wait till
I
someone brings
s-
up Elon Musk in my stream.
my first coding experience was manipulating network packets in order to gain advantages in online games. From there, I started learning C and then C++, and then eventually I started working in Python. Um, in the interim of that, I learned and then taught Java. Um, C sharp may be fine. I have not used C sharp. Um,
Is it just the
I,
scariness, or just like the reminding you of C and C that there's C in the name?
no, 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 not
Because
at
people
all.
have definitely
It's
come
a
to me with that, but
no, it's the concern that it's going to be like Java. The issue. Like, I was very glad to leave Java behind. I don't want anything anywhere near Java. I have not used C sharp. It might be fantastic. My college roommate who loves it has a very similar background to mine with starting in C and then learning C++. And he loves it. So hey, maybe it's great. I can do everything I want to do in Python, and if I want really
mm-hmm.
fast computing, I will use a Python library that's implemented in C and CUDA. And if I want really, really fast programming that I'm doing myself for some reason, then I can do it in C and C++. And I just, I also, I don't really, I do have interest, but I've never, it's one of those interests like I've never actually taken action on it. So can you really call it an interest? But like I've never done any game development. Like it's cool. I really like seeing people do it. I really like seeing what
It's
people
really
can do with
fun.
it. I hear that and I believe it. I just have like for me, everything I've wanted to do, I can do in Python very easily, very quickly. I know how to write good tests. I know how to handle the Dockerization and the deployment. I know how to take an ML model and wrap it in a REST API and deploy it and set up Kubernetes and Docker so it's scalable. Like I know how to do everything I want to do.
It's your
And
happy
like,
place. It's okay to have a
yeah,
happy place.
yeah.
Um,
This idea of going into another language just sounds less and less attractive the older I get.
oh no. Okay, so I think for me at least, it's probably that linguist polyglotness that I can't leave, which is just oh, it's so cool to see how it can be done differently. Um, that said, I totally feel like Python is the place I feel most comfortable as well. I will say that having now streamed a lot of science and tech and streamed myself coding Python, the hate for Python, I believe there are some valid criticisms of Python, but also largely comes from a lot of gatekeeping. Um, is pretty widespread. So it's also nice to also have someone back me up of like, no, literally, like you do machine learning, like Python's a great language for it. It really is.
Yeah.
Like,
Yeah, and
yes.
I did see the comment, and it's a common complaint about the white space in Python. And my answer is basically, look, use a code formatter, use a linter, stop worrying about the white space, and focus on the things you actually want to create. And like that's where I live. Like
Shakespeare. Yes, yes.
I don't care if it's tabs, I don't care if it's spaces. It's whatever I set my editor to 7 years ago, and I haven't changed it since. And it's it's whatever works with the code base. It's whatever's going to allow you to work collaboratively with your peers in order to create cool stuff in the shortest amount of time that is also
Yes.
robust, is also well understood, is also well tested and documented and logged. Like we care about creating quality software, and I don't care whether it's tabs or spaces
Oh,
or
this is just like
semicolons or curly braces. Like none of that matters to me. And again, I really started in C. So like I've done all the cool C hacks with macros and like I went way deep into that. And then I was like, okay, but let's actually build a system of programs that intercommunicate and actually do cool things. It's like, okay,
mhm.
well, this is time to put the toys away and I'll probably get a lot of hate for calling C and C++ toys and break out
I'm
Python.
sorry.
No, I know they're used for embedded systems programming. I know they're used to control airplanes. I know they're not toys, but like for me, it was like, okay, well, for what I want to be doing,
Yeah.
doing this in C++ is a distraction.
Yeah. And I think that's like, I can't tell you how many times I have been brought in literally to take something that was built in C or C++ and put it into Python because it's too, like, it is either too difficult to maintain or it's just like not as efficient to update the code base. There are lots and lots of reasons for switching to Python. And so one of my chat rules, by the way, is no gatekeeping. So I shut that down pretty fast. Everyone has their language preferences, all right? We all have the tools we like to get our job done. But like, I draw the line at when people start to shit on other people for using certain languages. I personally have had a miserable experience with JavaScript. I think that language hates me. I think it's sentient and it loathes me and it just wants me to fail. It's
I don't think the problem's you. I think the problem's the language.
Oh, see, like my ego's just getting a little boost here that it's not my like personal failure.
No. I am curious about Strophium's comment. Sorry, I didn't mean to interrupt you.
No, please, no, go. Respond.
I was just saying, he mentioned that if you're using GitHub, using tabs is a shit show. I use GitHub every single day, and maybe let me just check my code editor. Maybe I'm just using spaces, and that's why I haven't noticed that problem.
And while you're doing that really quick, Hannibal, so you ask, what is gatekeeping? Loafbone gave you a little bit of a half-assed response. Sorry, Loafbone. Mean that lovingly. But gatekeeping more specifically is excluding people from a community through like kind of nonsensical or invalid rules. So it's like, well, you're only a real programmer if you use Vim exclusively. And it's like, that's bullshit. You're only a real developer if you only code everything in assembly. Like, stop dick measuring. Like, it's not a thing. Okay, stop.
I taught Intro to Programming to computer science freshmen using Vim and C. It was their first programming language. They'd never done programming before. We taught it C using Vim on Linux servers, and they had to compile, and we went that route. Listen, it's just not worth it anymore these days.
That's how I learned C. But yeah.
I did check my editor. I do have spaces set to 4, and that's probably why I've never run into any issues with using tabs, because like I said it like 7 years ago and never looked back.
I like Vim for the quick edits. I like having something where I don't have to pull up a full IDE to make edits.
For editing and production? I'm kidding. I'm joking.
No. Like,
I'm joking.
There's like,
it's a
yeah,
joke.
okay, all right. You just like like there was that feeling of like, but no, like there's a reason IDEs exist. They have great tools. Like, I mean, I've seen the beauty of Visual Studio, the full thing, and Unity and that integration thanks to Strophium. But also, like, Vim's great. Don't get me wrong. I'm faster with small edits in Vim than I am like a giant IDE or something. But by the time that I have a huge code base, I'm not pulling that shit up in Vim. I'm not. I don't care if that like loses me cool developer cred. Like, no, it's really nice to pull that stuff up in Visual Studio Code and see like, oh, I've got like my architecture here. I've got all kinds of tools I can use. Like, no, sorry, no. But and Redneck W say Vim is awesome if you learn it. Once you add the right plugins, it can look like VS Code. That's great. Guess what looks like VS Code right out of the box? VS Code. And I don't mean that like rudely. I just mean like, that's fine. I've literally had on my to-do list explore plugins for Vim for like 6 months. But yeah. I get stressed. Like, there are, you know, tickets to handle and software to get done. And at the end of the day, I'm just going to pull it up in what I know best. So
I got really good with Vim a long time ago and had a bunch of plugins. And it can be very comfortable and very nice, but also VS Code's very accessible and easy to use. Yeah. And I use them both probably equally because I end up debugging on our servers sometimes, and so that ends up with me editing code in Vim still. Mm-hmm. Somebody mentioned Nano and Notepad++. I
used to use Nano forever ago.
Oof, I used to use. I've very recently used Notepad++, but I use it for quick edits. I don't really use Notepad++ as like an actual code editor very much. It's typically for very quickly editing some files if the system I'm on doesn't have VS Code.
So to clarify really quick, I'm interested in Airman. You say if you have a strong opinion against R, you say it made you miserable in life. I hope that's not gatekeeping. So to specify, gatekeeping is where you would say real developers don't use R. Instead, you're just expressing a personal opinion. Everyone can have a right to a personal opinion. Like Tyler and I were just shitting on JavaScript. Like everyone can have a personal opinion, but we're not saying JavaScript developers aren't real developers. That's gatekeeping, where you're drawing a line in the sand and saying like, you can only be part of this club if you follow this like asinine rule that just so happens the person often saying it follows. And there's love in chat for Sublime. I've used Sublime. And Adam, I've used that too.
I used Sublime before I came to VS Code, yeah.
Yeah.
And Sublime is one of the only editors I've ever used that was able to open an extremely large text file and not crash, because most Electron-based apps can't handle opening a file that large. But on that note, when are you ever going to be opening a several 100 MB text file? It was for an HPC class, and I had an idea that was a dumb idea. But Sublime handled it, so.
Nice.
I'm looking for
I used Sublime for a while. No, what were you looking for? Tyler, did you see my question about Lisp? I think he asked you if, let's see, or hold on, Hannibal. I saw that question and okay, so Hannibal, they say, how much is Lisp used for machine learning work? I want to learn Lisp. Oh. It just looks cool. Is that your reaction to Lisp? You're like, oh. Yeah. Looks like Lisp gave you a migraine.
Yeah, it's not Lisp so much as my eyes are getting a little dry. But yeah, I if I'm remembering correct, so first off, caveat, I don't work with Lisp. I have not written Lisp. I have read Lisp occasionally and said, yeah, I don't want any of that.
Damn. All right. And so you and I must think very differently, because I saw Lisp and I was like, oh, I want to learn this. This looks cool.
Oh, man. Maybe, see, now that you say that, I'm wondering if I'm thinking of the right thing or if I'm thinking of some other thing. But to answer your question, I can't answer it other than to say I don't know anyone who uses Lisp for machine learning. I'm sure they exist. I'm sure they're out there. I do not personally know anyone who's doing machine learning using Lisp.
Yeah, same. I would say the other languages I hear of most commonly for machine learning are like C#, Julia, C++, R. Well, like data science with R, but I'm not sure I've seen explicit machine learning in R. But that's just might be my ignorance.
R has some machine learning stuff. And then, I'm sorry, I was trying to read and listen at the same time. Did you mention MATLAB? Because that's another big one.
Oh, I'm sorry. That's some high school trauma there. So I don't acknowledge MATLAB exists unless I made the deep, unfortunate mistake of casually mentioning to someone at work that I had done MATLAB in high school. My high school at the time was the only one that offered MATLAB, which was cool. I hated it. I was miserable at it. And it just was a bad experience. And lo and behold, my very next project, I got put on to, do some MATLAB code. And I was like, oh my God. I just, no. Capital N, capital O, no. That's my feeling about MATLAB.
It's like AS400. You only mention that language away from work or in the most hushed whispers. You don't mention that you might know how to do it or read it, because then the rest of your career is now an AS400 programmer or a COBOL programmer.
So the funny thing being,
unless you want to do those things.
The data science version of that, I feel like, is mentioning things like dashboard creation or visualization. Yeah. I literally have had to. I thought some of that was interesting for a little bit, and then I started to get pushed into these like solely like aesthetic in the sense of creation of things that look good roles. And I was like, wait, I do machine learning. And instead it turned into like just everything about dashboard. I hate that word. I never want to hear that word again. But really quick also, Spike I'm trying to read your like leet speak here, friend, but thank you in any case for following. And Pancake and Hinga, thank you for following as well. I know you can love MATLAB. Like that is probably my own personal MATLAB deficiency. So, but God, if you're interested in data science specifically to do machine learning, do not learn Tableau. I don't care if this is like not something you can put on your resume. Do not learn Tableau. Do not say that you are a data visualization or dashboarding expert, or that will be what you do always. And you will not touch a machine learning algorithm. I swear. Like it's one of those things that, I don't know. I feels about the dashboarding because I got put in one of those roles for a little bit and I was like, I'm so tired of sitting here arguing with the client about like line widths. I don't care. I don't care. Like there are brilliant people out there who can do design, who have an artistic eye, who love being able to create things that look good. I'm not one of those humans. I'm just not. But, oh no, soapbox. That was a soapbox. Well, thank you for the soapbox counter. But data visualization can be very sexy, Strophium. But if that is not your thing, it's like there's a high demand for people that can do it. But if it's not your thing, be very careful because you can kind of get like sucked into it, and then like you get pigeonholed in it, or like typecast, and you won't be able to leave. But if that's your thing, like go for it. Like some of my dear friends do like data visualization or design, and that's amazing. But like if that's not your thing, I'm just saying that it's like what Tyler described, where talk about it outside of work, because people are hungry for dashboards.
Yeah, one of my very close friends does user experience design and user interface design, and she's very good at what she does. And I am just like, I'm glad there are people that like you who enjoy this and are good at it and want to do it, because I am awful at it and I don't enjoy it, and I get so mad that the colors don't look the way I want them to, and start questioning whether or not I can even see colors correctly. And so
Oh my God, yes.
It's not
I feel you. Anytime I try to make some like pretty data visualization, I just get angry. I'm like, can somebody who actually knows how to do this shit do this, please? Like, I will give you the numbers. Can you like make it look good? Because I'm so tired of sitting there trying to desperately wonder what font I should use, or what size it should be, or what hue of what color or something. And I do not have an eye for it. I don't. Like, give me the math. Give me the super back end stuff where nobody's got to look at it and say it's pretty. And I will pass it to far more brilliant people than I who will make it look pretty. Papa Payne, thank you for following. No, go ahead. You can make one hell of one.
Command line interface.
Yeah, so that was literally funny story. I was working on something where a demo was needed for a non-technical audience. And I had this like, oh shit moment of just like, I don't do GUIs. I don't build the things that the user clicks. So I was like, I'm gonna make a really pretty command line interface, and that's gonna be it. And it was just like some ASCII prettiness and like good arguments, and that was it. I was like, this is my demo. Deal with it. But I feel you. I have incredible respect. I love working with people who do UI UX stuff. That's the dream, is that like I want to have somebody that knows better than me how to do these things. I don't want to do them, but I want to work with somebody who is way better than me at them.
Yeah, I think that's like one of the biggest things I've learned in the last several years, from when I used to be immature to where I am now, is like I
oh no, are you like, an adult now? Can we still be friends?
Unfortunately, I don't know. I thought you were an adult. I thought, what are you?
Am I an adult? Really? Am I? Do I have to be? I'm gonna be 30 this year. What the hell?
Do we have to?
No. Do we have to? I don't want to grow up.
I don't think we do. I think we just play with the dogs and stay children.
Yes, there we go. I like this idea.
But no, like, so seriously though, like I have such a huge appreciation for the team I work with and the diversity of skill sets and opinions and experiences. It is invaluable. You cannot replace it. It's just like having a diversity. Having diversity is so important, and
From
Because it's
like
like I only
multiple kinds of diversity too.
yes,
Yeah.
and I mean all of that kind, all of the kinds of diversity, all of it is super super important. Because I've got my opinion and my perspective, but what the hell's that worth? I mean, I'm one guy, and yeah, I've got some experience and doing some things, but like we were just talking about, right? Like neither of us is the person to design a user
Hmm.
interface that people want to use and understand how to use, and it looks good and represents what we're doing in a good way. Like we're not
Yeah.
the people for that, and those people who like doing that are invaluable. And specifically, we're talking about UI UX here, but like
Lots
whether
of different things.
yeah,
Like
a PhD in
database
stats or
engineers, like a really really good database engineer is like magical.
I did a
Amazing.
lot of that in grad school. It's a lot of fun. Um, but
No, thank
yes, like
you.
yeah, it's yeah, I yeah.
It's yeah.
So
This is why having also though something that I found from the like diversity perspective, that's really invaluable on a team that has come in handy more in more ways than one is having people with really weird backgrounds. And so I say this as somebody with weird backgrounds, so I might be biased, but like it's amazing sometimes sitting there looking at, I don't know, maybe we're looking at a computer vision problem to detect dogs in an image, because dogs are on my mind right now. And you know, somebody on the team has a background in like, I don't know, like Just As Good Joe has a background doing like really cool gene stuff that I don't understand. But I've literally been on teams with people with like biology backgrounds who are like, hey, actually, this has nothing to do subject matter wise with what we're doing, but I really think we could use this approach from biology or genetics or something to solve this problem that seems unrelated. I've used problems from astrophysics to solve cybersecurity issues. Like, it's so cool if you have a bunch of people with really weird backgrounds, because you're going to get a lot of different ways to solve a problem. And it's very, very handy. Instead of the conventional, like, we all have the same background, we've all studied the same things, so therefore we're all going to, like, think of this similar things first. It's good to have that, like, I don't know, that difference in backgrounds.
yeah, no,
Strophy says astrophysics to solve cybersecurity. Got a hacker shoot him with a meteor. Not quite. But
no, I completely agree. And one of the coolest things I saw at a conference one time was I saw a group of students who were presenting their work, and they took the binary file of like a program, and they basically took the binary values and created an image from those binary values, and then they trained a DCNN on like malware. And so like they could do malware detection based on an image representation of the binary encoded data like of the
what?
executable.
Oh, that's really cool.
Yeah.
Wait.
It's kind of weird because like the whole thing of DCNNs is like the spatial like
Yeah.
information, but like it worked reasonably well. Like, hey, like that's cool. Like wouldn't have thought to try that, and that's neat.
I feel like the kombucha girl right now. I'm like, well, no, maybe. Ooh, actually, yes. I don't know. Like, oh, that's weird and cool, and
Yeah.
I don't know how I feel about that. But that's
Yeah,
really
there's a lot
interesting.
of yeah, there's a lot of stuff we do that leaves us feeling exactly like that because it's like that really shouldn't work, but it does. So I guess I kind of
Hmm.
see why it does, but it really
Yeah.
shouldn't. Yeah,
Oh, the
there's a lot
best
of
is
that.
when you're trying to teach someone something and you're like, let me show you how it's gonna go badly. And then you do it and it works great and you're like, it's magic. I've been there
Like
so many times. Like,
yeah,
oh.
like when you're purposely trying to be like, well, this is important because when we don't do it, this happens, and then you like chop out all of the parts that are supposed to make it robust or like good, and then it still works. And you're like, well, it's
Mm.
just overfitting to the training data. Let's just take me at my word for
Yeah,
now.
just trust me, please. I had a stream like that where I was prepping for, I forget which stream of for machine learning miss, and I was like, oh yeah, like we get this accuracy, so I'm gonna remove these features, and it's gonna do worse, and the accuracy shot up, and I was just like,
Yep.
well, thankfully I prep before stream because no one's ever going to see this.
Well, and that's exactly why, to loop it back to what we were talking about, ethics and
Mhm.
bias, like that is why it's so important to understand the performance of our models and the
Yes.
way that they work, because the computer's able to see patterns in the noise that we will never be able to see. And
Hmm.
so we have to be very intentional and very careful with what we're doing and
Yes.
how we're doing it in order to, it's not as easy as, oh, we'll just remove the gender identity feature from the data. Like, it's
Yeah.
not that simple, because there are other ways, depending on how much data you have, that that variable you think you've
Can be
removed can pop
inferred.
back up.
Yeah.
Yeah,
And like
exactly.
the
I know
like
you.
yeah, like multicollinearity and stuff. And that was actually one of the streams is where I was like, well, I'm going to show how bad multicollinearity is, and like, look, there's this feature that has like this high degree of correlation with something else, so I'm going to remove that. And the accuracy just went, and I was like, oh, okay, well, I know nothing and this is magic and I'm just going to like go with it. But like for a oh crap, it's 10 minutes before stream, that's fine. But if this was something I was doing for work, like that's where you need to really understand what you're doing, why you're adding features, why you're removing them, what happens, what metrics you're using to evaluate performance, what they mean. Like, I know that sounds almost like I feel like I've spent the last 12 streams trying to make machine learning as accessible as possible. And then now I feel like at the very end, it is important though to talk about like, I want it to be accessible. I want people to get interested and to learn it and to feel like they can do it too. At the same time, though, I feel like there's a lot of well intentioned, people who have done just a little bit who apply models maybe to things they shouldn't or data they shouldn't or get results that aren't valid but seem like if you didn't know better that they were great, and it can cause way more problems than you think because given that so many people view machine learning as a black box, there is sometimes either it can be like this innate distrust, which is one thing to work on, but often there's like a lot of innate trust of just like, oh, well, the computer said it, so better better just trust it. And it's like, especially if you have someone that is not able to like, it's a lot of power. Like with great power comes great responsibility. I guess we're superheroes now, but seriously, if you're going to build these things, you need to be able to explain it. Wait, no, it's not okay to also objectify Tyler Loafbone. No, just because he's a guy, if somebody comes in chat calling him hot, like, let's be respectful. Love was like, it's fine to objectify Tyler because he's fine. No, like, let's let's be respectful of all people in stream, please. Oh my god. Tyler.
I'm blushing now. Um,
But he's a cutie. Okay, well, I'm Tyler Pilot's Omega Chad. I don't even know what that means, but that's probably a meme of some kind. But okay, there you go, Tyler. Should I change your tag to ML Engineer Omega
please,
Chad?
please don't, because I'm not sure if that's an insult or not. I don't know enough about
I feel like
it.
a chat is a good thing. It started this like weird alt right meme, and now I think a chat is actually a good thing.
Okay, because that I
I don't
only know the
know.
alt-right meme, and so it's like,
Yeah, I try to stay away from anything that reminds me of alt right memes, but chat is a country.
yeah.
Well, also that. But
Well,
I'm gonna leave
yeah.
chat in your hands briefly. Oh, Omega Chad, and I'm just gonna grab another drink real quick. But
Okay.
I will be right back. Don't don't destroy them, but also
Uh,
yeah, like you all have Tyler to yourself for a second, and also Pro Ferdine. Thank you for following. I will be right back with a beverage.
okay. So if anybody wants to throw up a question, I will do my best to answer it. That may have not been the right words to describe that. I just saw it. The things that I saw, it was like, oh, well, maybe being referred to that way isn't such a great thing. What's up, Don't Drink and Drive, bro? Ant07, so the question is, Tyler, what are your thoughts on diversity in the industry? I think that diversity is very, very important for a lot of the reasons that Jess and I were talking about earlier. I think that the best solutions always come from a collection of people who have various backgrounds working together, and that requires a lot of mutual respect and understanding. And I have seen what's going on in the world and country, and I won't really get into all that here. I want to soapbox on somebody else's stream, but basically, personally, I listen to what people are telling me, and I try to do anything I can to help um, make a positive impact. So I'm sorry, I'm not very well equipped to answer that question, other than it's a concern, and we would preferably have more diversity because that is very invaluable. I know nothing, almost nothing about time series analysis. I have a friend and colleague who knows a ton about time series analysis, and he works with it, like that is his primary field that he works with. Um, and so all I can say is that it's cool, it's complicated, and I am not very good at it. Why ML and not CE or ME? So the reason I got into ML, I was explaining earlier in the stream, was that basically my graduate studies advisor does machine learning and computer vision and remote sensing systems, and I took his high performance computing class, and I really enjoyed it, and I really enjoyed the challenge, and I also enjoyed everything I learned from that class. And so I stuck around with him, and that's why I got into ML and not computer engineering. Or I never really was considered, if you, by ME you mean mechanical engineering, it was never on the table for me. I was doing network packet things and programming things since I was literally like 15 by myself in my parents' basement on
Oh,
a
don't be a
very old desktop.
stereotype.
When I was in high school, I mean, yeah, I was living with my parents.
So it's like the basement parenting. I'm sorry. Did I miss your answer for the what your thoughts are on diversity in the industry? I'm sad I missed that.
Basically that it's very important for all the reasons we discussed, and I felt like I was not very well equipped to give a very good answer. But I just spoke to how important it is and how we
Hmm.
need more of it.
I would add a slight to use our industry terms to piggyback off what you were saying. Um, I think it's diversity is just one step, but it's not just about having a certain number of different people with different genders or racial identities or whatever. It's more than that because you can't just cram like a bunch of say women, for example, into an environment that is sexist because they're going to not do well. So it's also about cultural change, and it's about having supportive environments that allow for diverse people to succeed. And so it's not like diversity. That's why I like saying inclusion, because it's about removing barriers of all kinds for people, so that all people can participate in the industries of their choice. Um, but it's really important to not view things as numbers, and like while that can be a good sort of like, hey, if we're like we only got one kind of person here, like maybe we're missing out on something. Build to fire. Thank you for built o fire. Thank you for following. But it it also, like, if you're going to actually be committed to diversity and inclusion, it's important to also focus on the inclusion part. So it's not just about grabbing people and putting them in an environment. It's also making sure that environment is a place where they succeed. So say, like, I don't know, paying women the same as men. So that's been like an ongoing challenge for me in my own career. But it's yeah.
Yeah, I mean, my personal opinions on that, and I'm very open, and you and I have spoken in
Oh
private,
yeah.
very directly about those types of, like, about pay and what I make and what you make.
Yeah.
And
I've appreciated you being very open with me because it's also been like,
Mhm.
oh, I'm gonna ask for more. So that's
Yeah,
helped immensely.
yeah, and there it's I don't know. I don't want to be like just say the thing that everyone says and say that there's lots of things that go into it, and honestly, I don't know. I'm very appreciative. I want to be clear just because we're talking about this publicly, even though I won't say what I do make. Like, I am very appreciative of what I make. Um, and you see the salaries that are out there, and you can get a sense for where that falls in line with what other people are paying. I've also, I moved to LA and I made a ton of money, even for someone in our industry.
Yeah.
Kind of an obnoxious amount of money. So sometimes it's just down to right person, right place, right time, and the chutzpah to stand your ground and demand a price, um, and say, if you want me to move across the country, this is what you're going to pay me. And
Yeah.
sometimes they say yes, and so
Well, to comment on that, and also ATX Pete saying, you said you found that men can be more willing to ask for more. Well, friend, that is also because women disproportionately get punished for asking for more. And so this is why, like, there was this massive thing, this study that came out basically about people negotiating salaries. And there was this push to just be like, well, women do what men do and ask for more. And what happened is that women were not given job offers. Whereas, like, for men, it seemed as a positive thing to renegotiate your salary or to negotiate a job offer. Women were punished for it, and that job offer was rescinded. I'm not saying this is, like, categorically true 100% of the time, but in terms of, like, the times it happened to men versus the times it happened to women, like, obviously it was more of an issue for women. So, ATXP, your ex being less willing to ask for more is probably because women are way more vulnerable when we do. And so I've negotiated job offers. I've never felt comfortable with it, honestly. I haven't, because I've had way too many times where me even just trying to ask about benefits or something is like, do you really want this job or don't you? And it's like, okay. Whereas I've had friends, male friends, who can negotiate their salary, and that's fine. So you also have to see that, like, it's not just, I think you have, like, an air of, like, causation there, because it's not that women are less likely to do this and therefore they're not getting it. It's women are less likely to do this because they've tried and it ends badly. So same thing with, like, oh, be more assertive. I can tell you I tried that as well. Like, oh, you should be more assertive and people will respect you more. I just got called a bitch. So it's very, very different how those rules get applied, and it's not as clear cut as just act like men. It's a lot more complicated of a problem, unfortunately.
yeah. And the fact that we've had such a huge disparity of difference of experience is one of the reasons why having these discussions is so important.
Mm-hmm.
And I've been I've been incredibly lucky in my career, that I have happened to meet the right people, happened to do the right things and say the right things at the right time, and I'm very grateful, that I've had such good experiences, and it's because of that luck, that
Luck and
and that
yes, luck and talent, though. There is talent there too,
well,
so don't cut yourself too short.
and honestly a lot of privilege too. And it's like I would, if somebody came back to me and said, "Well, how much do you really want this job?" My response would be, "You know what? Not at all. I'm gonna go somewhere else." Like if
Mm-hmm.
that's how you're going to handle this interaction, and me asking about benefits or asking about what is the salary range that you're offering for a position, if that question makes you respond that way, I don't want to work for you. And
But that's
that's
also
it.
you coming from a place of likely having financial stability. So, like, at least in my experience, I have been way less likely to be picky when I've needed the job. When I'm like, I'm out of
Yeah.
work and I need a job versus like now I'm employed and you know, I get
Yeah.
interview offers or whatever. And I'm like, well, now I can be particular because who cares? You don't give me the job. Like, fine, I still have a job. So I'm good. So I also think
Yeah. I
there's
mean,
that caveat there as well.
well, I mean that we're the same in that way, in that yeah, I definitely, if I were to be out of work, and thankfully I have not been out of work in a very, very, very long time. So I'm always in a position of I am somewhere, I am happy, someone's trying to recruit me. Um, and if I were in that situation where I needed something to pay the bills, then, I definitely would be. I don't know. If I to feel like I'm being honest, I have to say I would put up with a lot more of that. But also, part of me is like, well, no, I would adjust my lifestyle and I would
Hmm.
would work, uh, you know, part time for university or something. Like would just make less money and not. And especially also, we're having this discussion after I just left a company for reasons. So the way
For
I feel right
reasons.
now might be a little
Influenced by recent. I mean, you just,
yeah.
generally speaking, you took a significant pay cut for a
Yes.
trade off in terms of the people that you work with and
Mm,
the, work life balance and things like that. So I do feel that, like, but there also is a privilege there of, like, once you
yeah.
hit the amount of money where you can pay your rent, you can pay your bills, you can get food, like, it's okay. Like, you're not working entirely paycheck to paycheck. Like, you feel like, okay, I'm not panicking if like my tire, goes flat or something. Then I feel like then you can make those decisions. But a lot of folks who, the vast majority of Americans at least, don't have the luxury of being able to wonder about, making, like, taking pay cuts to be able to work in better environments, like, so I feel like it's hard
Yeah.
too, because I feel that way as well. Like, I'm, very much aware of, every time I complain about my own work struggles, that comes with, like, an immense amount of privilege related to, well, I can pay my bills. And especially
Yeah.
during a massive pandemic where unprecedented numbers of people are out of work, like, that is a huge privilege that I've been trying to be more aware of, despite the bad days at work. Despite
Yeah.
the aggravations.
Yeah. I mean I think we've talked about this in the past, but I have been on both sides of this equation.
Mm-hmm.
I have when I was in school, and prior, um, I've had nights thinking, okay, rent is due Friday, and I have X amount of money in my bank account, and rent was a very small amount because I had three roommates, but I still was wondering, how am I gonna buy food
Yeah.
and pay rent? And
Mm-hmm.
I've been in those situations, so I 100% get
That
it,
was
and
me in
it's
graduate
huge.
school. Honestly, it was
Yeah.
like there were times that I sold consoles to pay for rent sometimes. Like, there were plenty of times that I did not know how I was going to be able to get by. I think that, so, Mediocre Gamer says, it's interesting coming from a military government background. If I told you my rank and how many years of service I had, you could all Google it and you know how much I make. Well, that's
I think
also
that
why
will.
I'm a fan of set salaries for certain positions, so that people can't be like, well, we're going to offer you a little bit more. And suddenly you find out, especially me, I've gone around and asked male coworkers and found out that people with way less experience and credentials than me made way more. And I was like, excuse me? And so if it's all set based on your title, I mean, that's just an ignorant view. Like, this is not, I'm not like an expert in sociology of financials or whatever this is, but, like, I feel at the very least that kind of um, uh, transparency would prevent some of these issues.
Yeah, I really love the transparency that the military and government background have, and the published pay levels, and it's just like, if you do these things, we will pay you this amount.
Yeah.
It does set a cap on what you can make,
Mm-hmm.
which is certainly a trade-off. I think that transparency and openness, and it's, we talked about recently. I've recently started to turn the wheels to enter in a managerial role, and so I'll have access to some of this information. And obviously, I will not be able to share it with anybody, but have a
Yes.
conversation with the person who I'm responsible for. Um, but like on the other end of it, I like personally, I'll tell not here online, but in general, I'll talk about things with anybody who wants to have that conversation, because I think
Mm-hmm.
transparency is so vital to running an efficient and fair business.
Yeah. I mean, I think so. The set salaries also comes with a trade off, I think, to kind of address some of the concerns in uh, in chat. I think it also depends on where you live. And I don't just mean like where in the US. I mean, like, if I lived in a country where perhaps I might not go bankrupt if I got sick, then, like having a set salary wouldn't matter so much if the vast majority of those concerns were taken care of. I do think like some flexibility, I worry every time you give that, oh, I need flexibility in salaries, it is used to disproportionately harm the people that we should be trying to help as a society. And so it's like, you know, I'm white, but as a woman, I make like 80 something percent on average of what men make. And, you know, that if I weren't white, that would just like, you know, continue to drop. And so I worry that those ranges, those salary ranges would be exploited, unfortunately. That said, like, I feel like complete transparency is at the very least, a first step. So if that information's public and like available, then at least there's like a way for people at, you know, instead of having the awkward conversation of trying to make friends with people, be like, well, how much do you make and how is this an okay time to ask you? Like, thankfully, like, we've had that conversation, Tyler, but we're friends, so it's fine. And I also was like, okay, well, like, I have some, like, I renegotiated my salary at the beginning of last year in no small part to conversations we had, because I was just like, this is ridiculous. But at the very least, I think transparency is a good first step to being able to address some of those systemic differences, shall we say.
Yeah. And I saw a comment about the fact that you and I still aren't sharing what we make on stream, and it's kind of like, well, if you don't work in this industry, if you don't have the background information that we have, then it can be a little jarring, but it's like for the industry, for what people that can do what we do, the kind of salaries they demand, because the market will bear those salaries.
We make less on average than the market average for people with our skills. But the trade-off being, like, the place where we work, at least in my opinion, has performed better than almost every other place I know of in terms of the pandemic. And there's work-life balance mostly. There's great people that both Tyler and I really enjoy working with, and Tyler gets to work with those people more often than I do, but still, they exist. They're wonderful. I hate you, but it's fine.
Comment. I will text you later.
Yeah, give me the deets. But
I mean, well, no, it's a conversation you're putting off.
Oh no! But no, I have to talk to other humans. God damn it, no. But no, I'm so bad. I don't know why I have a degree of social anxiety about that, but I do.
It's in your court, Jess.
I know. I hate when the ball's in my court. But so I think, you know, those trade-offs we're willing to make. I mean, I got a job offer at the start of the pandemic for what would have been a significant pay increase, and I turned it down because where I work had just announced all of this support for companies or for employees during the pandemic. And it is just, I felt for the first time, like, usually I'm used to like feeling like I'm kind of being exploited by the place I work, but at least during the pandemic, for the first time in my life, I felt like a corporation had my back, at least, even if it's temporary. And so I stayed. But also I would say I think another reason that at least for me, that I'm not going to share how much I make, is I've been told explicitly I can't. So.
Oh, have you?
Mm-hmm.
That's interesting news to me. Sorry, I'm actually texting my wife right now. I'm not trying to be.
No, please. Oh my God, wives are important. Wives are number one. Wife greater than stream. Go for it.
But that's interesting. That's news. I have not been told that.
Yes.
I don't like that you've been told that. I really don't like that. That's.
So let's see.
We were saying,
Yeah.
I just wanted to add on to what you're saying, though, about our employer. I feel very happy to be working for them. I think as far as I have, I worked for our employer and then I left for a while. and I worked at a very, very small company, and then I came back. And one of the big reasons I came back is, you know, I saw all of the things that our employer does to try to do the right thing, and really it sounds like, oh, it's so easy, just do the right thing, but it's not when you're that large. I think it's a lot more complicated because you're literally dealing with tens of thousands of people. Like
Mm-hmm.
it's not as simple as do the right thing forehead. But it is having said that, it also is that simple. And they do it. And so like I saw them doing the right thing, but I didn't appreciate it as much as I do now because I saw people who don't always do the right thing or don't always treat people correctly. And it's like, wow, turns out this is super, super duper important.
Mm-hmm.
Um,
Yeah.
like I'm very happy and excited about working with a group of people who do the right thing and who are very focused on it. I mean, even not to get into recent events, but I'm sure you saw the email from our leadership that
Yeah.
came through yesterday. And so
Mm-hmm.
it's like, well, that's that, you know, and I've personally seen leadership in my area who have made strong statements that I was, just be honest, nervous about making because of where I live and who
Mm-hmm.
my family is. Um, and it was like, well, okay, well, you know what? No, this is the right thing to do and the right thing to say. And um, it's really important to see leadership do the right thing and not just like hear them talk about doing the right thing, but
Yeah, but
actually
back it
see
up with
them do the
actions.
right.
Mm-hmm.
Yeah, yeah.
Like at the start of the pandemic, they froze all raises, bonuses for like upper level, and canceled all like retreats and parties and things. Banked that money into a fund for employees who might get affected by COVID. Gave us a butt ton of paid time off if we got COVID or a family member got COVID, and also froze all firing for months. Like it was like 6 months during the pandemic. And so it's got to be backed up with actions because I think I've seen so many companies pay lip service to inclusion and pay lip service to having their employees' backs. And when you do have a company as large, it varies across the company, but it does mean something to feel like when my family when my brother and I ended up getting COVID back in April, the amount of people that reached out to me to make sure that I knew I could take paid time off. Don't you worry about anything. Don't you even worry about emails. Like it's okay. Like don't even stress. Like we have it. I was like, wow, okay. Like I feel all right. Like I can probably work for a couple more days. Like if I push through. And it was just like, no. Like take care of yourself. Take care. Family comes first. Like when my mom had a stroke, I remember I had a huge day full of meetings with clients, and I sent a like single line text to my career manager, and I was like, my mom just had a stroke. Like I need to go. I left in the middle of a meeting, and my career manager was like, I've got this. I will handle everything. You don't work. Don't check your phone. Let me know if she's okay, but like go. And I was able to, for the next 3 days, spend all that time in the hospital and not have to sit here thinking I'm going to get fired for walking out. So there are perks, and that kind of commitment to your employees is something I think should be kind of like, I don't know, commonplace.
Yeah,
But
not
as we've both learned the
not
hard way, it's not.
yeah, not to go too far into the pile of garbage. But you know, my previous employer did not have a COVID policy until it's like July or August when a few of the employees kind of lost their cool about the fact that there was no COVID policy and
What do you mean by like a
that
COVID
thing
policy? Like they just like business as usual? Like nothing
like
changed?
like there was no policy, there was no strict rules. People were just doing whatever they felt they wanted to do. Um, and we were in
Oh
LA
boy.
County, and it's one of the worst spots in the country, and it's like we have to go to work, and it was yeah. There was a lot there that was very much not good. I'm very happy to be at a much better place now. Um, but yeah, like that's just like something as simple and predictable and literally just do this thing. There's a global pandemic, make a COVID policy. whatever you want it to be, just make it. Like, and then we could talk about whether it's good enough or not later. But the fact that it took, I mean, I don't remember if it was June, July,
Oof,
August. It was way
that
too
is
long.
late. And like where we work, at least, I was really impressed with this because my I have a family member who works here as well, and they work in kind of an environment where like working from home would not be very easy, and it often would not be feasible. Like for me, I sit on my ass coding all day, like ideally, or stuck in meetings. But it's very easy for me to work from home. I was working from home 90% before the pandemic, so it wasn't a huge transition for me. But what I was really impressed with is how quickly there was a policy implemented where it was not just if it's at all feasible for you to be teleworking, you will be, but also if your project is demanding that you have to go into work, they better meet our like
Right.
specifications for how safe it's going to be. And those specifications were like intense. And so it was like,
Yeah.
no, if you want our employees in your building, you're going to meet our standards for safety. And I was like, okay, that's
Yeah.
great. Like it's not perfect, but it's great. Like, oh,
Yeah.
and that was like for essential workers though, third tier gaming. That was for people that like
Yeah.
have to
There are
go
some
into
people
work.
who have to go into work for reasons, and I was one of those people for several months.
I know. I was so worried honestly when we were talking over the summer, especially because it was just like, especially now with LA County.
Yeah.
But it's
Yeah.
I'm glad that you were safe.
Yeah.
But oof.
And it's especially bad because it's like, we're a government contractor, and it's like, oh, our client has policies, but we don't have any policy.
Yeah.
Like, at least borrow theirs. Like, what?
Yeah, I'm
Like,
talking
how
about
can you?
almost the reverse. Yeah. It's
Yeah,
just
like, how
like
do you have nothing? Like,
mm,
yeah, yeah,
yeah. So I mean, this is
Hmm.
like just like with machine learning. There's so much more that goes into it than just the things you think. Like it's I mean, for the longest time for me, it was just about the salary because I was like, I need to be able to get food, and like I have a chronic illness. I need to be able to afford my medicine and like my doctors and stuff. I have to go to the doctor way more than most people. Like I need these things. Um, and at least now I'm like, okay, as much as sometimes I do perhaps want to work for a place that focuses on different industries for ethical reasons, I'm at least when I specified outright, I will not work on X, Y, and Z, the answer was, oh, okay, no worries. Cool. Yeah, we'll make sure. Just let me know if you feel uncomfortable and we'll move you somewhere else. It's like, you still want to hire me? And it was like, yep. So that,
Yeah.
you know, I'm grateful for that. But
I was just gonna say that, like, they understand that, we're we're only going to be doing our best work if we're happy and okay with what we're doing, and they pay a premium for us, and so they want us to be doing our best work, and so it's always like that's what I appreciate so much because it's always been, if you're not happy, tell us for for all that is good in the world. Tell us that you aren't happy so we can try to do something about it so we don't lose you to a different company where you think you're going to be more happy. Like, let us fix it. And I really appreciate that a lot.
yeah. And I think, really quick, so Loaf, when you say we try to keep the channel politics free, I agree with that. I refuse categorically, based on science, to acknowledge the pandemic as being a political thing. It is a scientific thing. And I'm not going to disregard scientific fact in the name of like respecting people's politics. So that is one thing that I will, like, I'm not going to sit here and argue about term X, term Y. The pandemic is costing lives. It is a scientific fact. You wear a mask, you reduce risk. I'm not going to, like, that's not a political thing, that's a fact. So we have to make, unfortunately, we have to make that distinction right now. So my politics free channel, I will talk about science. Obviously, this is a science channel. But to respond to what you were saying, Tyler, it's that honestly. So I spent years in academia, right? Where like it's kind of like an abusive relationship, and I've been in those too. But it's like you're kind of told you should sacrifice everything just for the honor of working in academia. It's like this weird attitude. And the first time, the interview that I had when considering to work where I work now, I was floored and completely put off guard by a question I had never been asked before, which was, what do you need to do your best work? What do you need from us? And I was like, excuse me? Like, wait, you're my employer. Aren't you supposed to tell me what you need from me? Why are you asking me what I need? It was like, literally, like, and you know, obviously project by project things different, but it was like, do you prefer to work 4 days but much longer? Do you want to work like, you know, 6 days but shorter? Like, it's going to depend on project, but like, if you have needs, like, do you want to work from home a couple of days, like more frequently? Like, what do you need to do your best work? And I was just like, I've never been asked this before. I've never been asked what I need. And I was just like, there was a like, am I, what is it? Stepford Wives, right? Like, am I, what is this? What is this strange land I have stumbled upon? Like, what the hell, do you really care what I need? But
Yeah.
it might take a long ass time, but every time I've raised a concern, it's gotten addressed. So
Yeah. Yeah, I remember the feeling of like they I can
it's
feel what
weird.
you're talking about because
It's so
I have felt
weird.
it too. And it's like the first time I was talking to somebody, I was going through a really hard time. I was just really stressed about work and just about very stressed about doing really good work and
You
pushing
serious?
pu-
You really, Tyler?
I was pushing
Okay,
myself
all
very hard and
right.
so I was very stressed and I guess my manager had picked up on that. And so one day we were doing our regular conversation where he just like checks in with me and sees how things are going and you know things like that. And I had kind of gotten like autopilot for these conversations
Yeah,
because like things are great
been
because
there.
they were, and it was like and he goes, "No, like seriously, I need you to like stop and hear me for a second." And he's like, "How are you? Because you seem very stressed every time we talk." And I was like, "Oh, well, I
Is
guess
this who I'm
actually."
thinking it is? Is this okay?
Huh?
Uh, is this your previous CM?
No, it
Okay,
was my second job leader.
okay,
Um,
it's fine.
not the first one, but the second one. Yeah. Um, and I was just like, yeah, I was, I was just very like, wow, you like, I can tell you actually care about the answer to that question. And it like made me
Right.
realize that I wasn't doing so well. And then
Mm-hmm.
it like pulled me, and I was like, I need to like take a breath. I need to take a minute. I need to communicate that, hey, I'm trying to work on like 5 different things right now, and
Yeah.
I'm not rocking all 5 of them, and I need to take a day off and recalibrate and relax and come back fresh. And it was just, it's really, it's it's so important because as simple and as silly and it's like, oh man, Tyler's taking spent all his time talking up about like somebody asked him if he was okay and how excited he was. But man, I have been in places
Seriously.
like
But that is
where
never a question. That is never
yeah,
something someone asks. They don't give a shit. And
I have been in
John E5S, you say like you hate those talks. It's so hard to talk to the boss. Well, I will say this is that there's a distinction where we work between like your mentor, pardon me, you're like your career mentor and like your boss, your job boss. Now I've gotten those talks from both, but I have found that it's great that separation because the person who like is asking about your well-being, if it's not the person you like report to that is tasking you, sometimes it's a lot easier to talk to somebody that you feel like is your advocate. um and that can be that distinction of having two people that therefore are looking out for you but in different capacities, I found to be helpful. Because if I'm concerned about more of the job load or like something related to the work, I feel comfortable talking to my boss. But if I'm having like an emotionally stressful time, or I don't know, like now I'm dealing with like the other half of my family having COVID, or like literally since I've started working here, somebody has died every single year. Someone dear to me has died every year I've worked here. And dealing with that, I would reach out to my mentor more so. And that's the person who will negotiate with other people on your behalf. So it's kind of cool. It's like you have an advocate. You have like your boss, and then you have somebody who's supposed to be your advocate. And I like that.
Yeah, I really like that a ton too, and it's one of the reasons why I'm very excited about being able to function in that role for somebody else or for several somebodies, is because I care a ton about making sure that people are happy, and
I love doing the mentor role. That's my
Yeah.
favorite.
Yeah, definitely.
Even
Like,
if it
that's one
means
of the things.
sometimes the awkward thing, the person I was mentoring from June of last year for about a year ended up leaving the firm because this was not a project where she was able to move off of efficiently. And she had started out just like very low level kind of admin role and had developed a passion for data science, and on her own time like became brilliant with coding, with data science, was just in love with it all. And they weren't willing to really kind of move her to a technical role. So she got like this massive raise and this excellent transition. And I was like, I'm your mentor. I'm cheering you on. Like, that's fine. And I've literally had mentors say that to me where it's like, no, if you get a better offer and I think this is a better fit for you, I will tell you to take it. So those are the people who like advocate on your behalf, like separate from the place where you work. So it's useful to have that distinction, I think.
I totally agree with you. I also was very lucky that specifically for me, both sides of that leadership chain were very supportive. When I told everyone that I was leaving for an opportunity, because it was
I wasn't supportive. No, I was trying to be supportive. I was gonna miss you lots though, so I'm kind of glad you're back.
Yeah. But when I told my leadership, in various different places, generally across the board, it was, hey, we obviously can't compete with that. That's an amazing opportunity. I wish you the best. And by the way, we would be very happy to have you back should you decide that you want to come back. And so I was really appreciative of that. And that's actually, I told you this, I believe when we were catching up, that like when I reached out to the local leadership, and actually wanted to have a conversation with them, it was just about general career advice. It wasn't about coming back here. It was just about, hey, here's where I'm at in my career, and I trust your opinion. I value your opinion a lot, and I just love to have your perspective. And then just in the course of that conversation, they asked, well, would you consider coming back? And then I said yes. And then we are. Jess, do we know who Third Tier Gaming is?
Third Tier Gaming is being sassy. No, we don't know.
Oh,
no.
Okay.
He's being sassy about I missed you too. Yeah.
Okay. I don't know anyone's.
There's one other person from our employer that will sometimes show up in stream. But I don't think you know them. Nevertheless, I would say like I remember going through the god awful mind numbing new hire orientation that all companies have. And there was this moment of like,
my life this week.
Oh, we literally have a baked in policy because so many people think it's better elsewhere and then come back. And I was like, oh, like that's how ballsy it is literally like, we are so sure you're going to come back if you try to leave because it's better here, that we have all this stuff for people who come back. And I was like, oh, that's kind of cool though, that also there's no penalty. It's like, oftentimes you come back with a career boost, but also it's like, no, like go off. Like it's okay. This is going to be the most obnoxious comparison, but do you know about Rumspringa?
No, I have no idea.
Okay. So this is a concept in the Amish community where when someone turns like 18, they're allowed to leave. No questions asked.
Yes, I do know.
And like be out in the world because they're so confident that they're going to come back.
Yeah.
And it's like, that's what that reminded me of, is like, we are so confident in the environment and the quality of work that we provide to our employees that like, go. Yeah. Like we know you're going to come back. And it's like, damn, okay, Jesus.
Well, that's very true. It's also important to be clear that it's a supportive, genuinely welcoming return. It's
it's not like
try to escape, you'll come crawling back. It's a we would love.
That's a good.
We'd love to have you back. I do want to answer because I noticed third to your gaming's question, and I did see this earlier in chat, and I didn't feel like I had a chance to answer it. So
Oh yeah,
yes,
go.
if by ME you mean mechanical engineer, or really whatever you mean by that, I'm happy to have more friends always, and I am a huge believer in that the more diversity you can expose yourself to, the better. So it is totally okay that we do not do the same thing or have the same background because that just leads to more interesting stories.
Hmm. Yeah, and like that's one thing I've loved so much about streaming and also about like especially the science and tech community on Twitch, which Tyler we have a longer conversation about how I can steal you and let's make something together. But
Yes.
also it's a great community. Like I've I've really been so amazed at the cool, intelligent, wonderful people that I've met and how I don't know, how people like the support and the warmth and the welcoming has been very impressive to me. So, uh, oh, see, I'm like I maybe this is like an anathema or something, but I'm just like I'm the anti-Fang. I'm like, don't try to come near me. I don't want any of you.
Oh, that's funny. I interviewed with Snap, and I was
Oh, I
very
heard.
was very not happy
Mm.
with that process. And I interviewed with a few companies that was like, did you know who I was or what I was applying for? Like, what was that interview? It has nothing to do with what my job is. Do you know what my job is? Do you know what I do?
Yeah.
Yeah, hiring is a hot mess and it's difficult and I get it and it's challenging and I've read and discussed with people all the concerns about it and I get it. I get it that it's hard. But also as someone who's done the process and it's easier for me than a lot of other people in our world, it's still a matter of like why would you ask me this question for this job description? Like
Mhm.
this question,
Yeah.
this technical interview question has literally nothing to do with the job I'll be doing, and I know that because I've been doing that job for several years, and it's just like, why would you? Yeah.
Oh, yeah, gotta love those technical interviews.
I saw the warning
I think
political rants and lots of opinions ahead, and I don't know if that's talking about us or if that's
oh
just the
no,
people.
so fighting Pisces, welcome. Use the Twitter command in chat, and I put a warning there because I try to keep
Oh, okay.
my stream at least less political. A lot of times, at least in the educational
Nice.
streams, I try to be less crass. Twitter is like me, no filter, so
I
I put a
see.
warning there. But at least for me, I feel like my if I were to describe my fangs, so like my places that I would like would encapsulate the amazing places I would want to work are things like the UN and like I don't know, like MSF and uh places like that. So for me at least, the places I want to use technology are not like Facebook, Apple, Netflix, Google. So that's my personal because that's my career focus. That's not me like shitting on that at all. That's just me saying for me personally my career focus is elsewhere. So
Yeah.
but
I
virtual
want to.
assistant asks, do we have our own
Yeah.
AI that we built at home?
Do you,
Virtual
Jess?
assistant, okay. Well, virtual assistant, dear friend, you've been here for enough to know my feelings about the term AI. So are you asking me, do I have machine learning models I am running at home for things? Sure. Lots of things. Are they relevant? Probably not. Or do you mean, am I using products that have like ML as part of them? Because absolutely. Um,
I
uh,
I think I read that
yeah.
question as your own AI, like something we built, and then he says that you built.
Um, I have built complex machine learning models for funsies
Mhm.
that I use at home. Are they like that I use at home like on a daily basis because it's integral to my life? No. Um, it's mostly stuff involving video games, but
Oh,
yeah.
that's awesome. I'm super interested in hearing more about those.
Oh, it's interesting.
I
Yeah, we'll talk.
I brushed off the software engineering and built a bot to buy a 3090 when they were very hard to get hold. I mean, they're still very hard to get hold of.
I
Um,
remember that.
and I just used it to send me a text when one was available. And so I also built a basically a whole new computer to build really cool models. And I have been living in a whirlwind since that happened, basically. And so I have not had a chance to actually build anything really cool that's ML that we actually use on a daily basis. We're also, I mentioned this earlier in the stream, but we're currently in a hotel, um, and like closing on a house, and so we're like in between homes right now, so we don't even have all of our things, let alone ML model running on a regular basis. But I always want to like once we get really settled in our home, there's a lot of things I want to build when I eventually have time and resources.
Same. Uh, Third Gen Gaming say we all know Jess created Loaf Bone with the sole purpose of taking dog pictures. Loaf Bone, are you my AI? Did I build you and just not remember it? Because that'd be pretty cool. Xeno Dacian, you say next question: how many AI friends do you have? Well,
I have lots of friends who do AI.
there we go. Well, not for me. I think you are the only person, now that I'm thinking about it, that I would say is a friend that does like machine learning in any capacity. I try to keep work and private life separate, also because like tech can be a very dude bro culture, so I butt heads with people a lot of times who embrace that culture. When I find awesome people like Tyler who are kind of like different and awesome, and also we've had many post conference, post giant team meeting marathon drink sessions at various bars, which bonds, you know, the bonds of brotherhood. But also, I mean, at least for me, I do my best to make friends that aren't directly related to my work. And Hoo Boss, thank you for following. If you need, oh yes, Loafbone, you work in the morning. I can mod from here, so if you need sleep, please don't worry. I know Loafbone gets up at the butt crack of dawn to take care of dogs. So I'm so sorry. I forgot that today was Friday. Despite saying Friday repeatedly, I'm so sorry. So if you need the sleeps and you are staying up to be Mr. Mod, do not worry. I know how to delete and ban people. Oh yeah, I got the power. And yes, they're worth it, but also he's got to get up at like 5, so 5 a.m. And Hoo Boss, you say it's nice to find new ML content on Twitch. Well, friend, you were in the right place. If you are, if you're interested in more machine learning, I would recommend you look at the YouTube, YouTube kind of like backlog of the VODs. So, the VODs will cover all of these topics. Schedule. So those are all the topics of the 12 days of machine learning, miss. So if you're interested in machine learning, please check out the VODs, the GitHub, all of the above. And feel free to join Discord or just, you know, join in when you feel like it. And virtual assistant, you say buy at home, you meant as a hobby in your spare time. Oh yeah, then buckets O AI.
Oh yeah.
Mostly involving video games, but yeah.
The graveyard of started and not finished projects that were supposed to go up on GitHub and will never see the light of day.
Oh, I feel called out right now.
No, that's
Oh,
me.
man.
I'm describing
Oh, okay. I'm like, I could pull up my like literally my projects directory, and it is sad. The amount of things I was like, I'm gonna do this, and it's such a cool idea, and it's revolutionary, and I like got like maybe 10% there, and then was like, I'm stressed. I want video games instead, and like the project never saw the light of day. So, but
Yeah.
do you have any projects on your mind currently that you would like, if you could have all the time in the world and just the rest and the energy and everything to focus on something, is there something that you would really want to do?
Oh my gosh. I really love so if I had infinite money, I was basically retired and just was doing filling my day with stuff. I really love the ideas behind open source, and so I think I would be extremely happy to contribute to open source on a regular basis, but also working on stuff that has a way to contribute to society in a positive way. You know, and it's particularly when it comes to like allowing people to understand information that we can't process in any other way without computing. It's one of the reasons why I
Mm.
really love data science. And I kind of like have been in this role of being ML ops and ML building and CV model building, and like I've very remote sensing in CV. Like this is what Tyler does. Um,
Yeah. The
but
CV
also
wizard.
yeah, yeah. Which is not like I haven't resisted that because it's not a bad thing and it's a skill set that's very useful and is very marketable, and so it's I haven't like resisted it. I've let that play out. And I enjoy it a lot, but also like I really am interested in the other parts of data science too, and especially with like geospatial data and combining what with where and
Hmm.
finding new insights from that, which is something I have some experience in as well. Um, you know, I don't know, like there's no single, and I think I was gonna mention this earlier, but I don't know if I got to it, that like I don't think there's any single company or organization that I necessarily want to work for in particular. It's more about I want to work with awesome people, I want to help people grow their careers, and I want to work on cool stuff that has like real impact to people and provides real value to people. And
Hmm.
obviously I won't touch anything that I don't ethically feel okay with. Um, and so that's one of the reasons why I keep saying that I'm so lucky, and it's because I feel lucky because right now like I have that, and like it was kind of like mind blowing to me. I was having a discussion with a friend of mine, an old friend of mine, and we were talking about like high school hopes and dreams, and they were talking about a life change to go pursue their high school dreams. And they asked me, well, what are your high school dreams? I was like, well, they were X, Y, and Z, which I won't say here. And it's like,
Oh, you're gonna text me this after stream then. I need to know
yeah,
like high school dreams.
it's like, well, I kind of have accomplished them at this point in my life. So it's like, oh, I guess I need new like life goals because it's like I've kind of like objectively enumerating what I wanted at that time and comparing it to what I have now. I have those things.
Hmm.
Um, and so yeah, I don't know. Um, I
Really
guess I
quick,
just
Astro
really.
Jav and
Mhm.
Ronald Daku Trimph. Thank you so much for following and welcome, Astro Jav. I don't know if you're into astronomy or you are an astronomer, but welcome. That was a past life of mine, so you are in a great place. Welcome, both of you. Thank you so much for following. Uh, See, I feel like I envy people like you who have had this constant dream because I would say my dreams have changed every year or two. And so it's like a moving target, but that's okay because I love the process of striving towards something more than I probably like getting there. Um, because if I were to accomplish my high school goals, I'd either be a PhD in mathematics right now or I'd be a doctor. Um, Neither of which I am. But it's interesting just how, at least for me, the things that I'm interested in or the things I'm passionate about have like refined or shifted throughout the years. So
Yeah,
I don't
well, they
know.
have for me too. They definitely have, because like what I want out of life now is very different than what I wanted out of life then. I guess like specifically, I was thinking about like at the time of when I was in high school, like remembering what I wanted then, and
Hmm.
it was like I'll skip the details, but basically it was to girlfriend at the time, and I am very happily married now. It
Well, so to
was
have a
to
fulfilling relationship,
yeah,
you could say
yeah,
was a dream.
was
Yes.
really what I wanted. Yeah.
Hmm.
It was to work in cybersecurity, but because I wanted to make a certain
Hmm.
amount of money, and I make more money now than that number was. And so it's like, okay,
Nice.
well, I've gotten that done. And it's like I wanted to have a good job that I enjoy. It's like, okay, well, yeah, I'm doing that. Um, and I wanted to have like a really awesome house. And it's like, well, yeah, we close in 2 weeks. Um, So it was like, oh wow, I guess like the only thing was having a family, and it's like that's not immediate, but it's we've those are discussions we've had, and
Hmm.
so all of the things I was worried about are kind of like I'm in a good spot with my life for them. So it's like there's nothing left from high school, and then like what I want now is very different. It's
Yeah.
more focused on helping people grow their careers, being an advocate for people, helping them understand their own value and potential, and helping them reach areas that they may have doubts about being able to reach, and helping them realize their own self-worth and being able to
It's such a good feeling
actualize
to
it.
do that. Yeah.
Oh yeah.
That like, I don't know. I find that one of the hard lessons, especially that I learned throughout the pandemic, was just how critical my volunteering was to like my happiness and my mental health. And so the inability for me to do my normal shtick of spend a lot of time at the fire station, and in between calls I do work, and that's fine because I work from home, so I can pace it however I want, and that's great. Having that denied to me really made me see like how much I need that sort of like that service aspect of life, to like whether it's mentoring someone at work and helping people grow their career, or riding on the ambulance, whatever it is. It's like I need that like act of helping in some way to be happy. So it's also like, I guess for me, it's funny because thinking back to being a high schooler way back when, I'm not even sure. I was thinking about like being married and having a family. Like for me, it was all so intellectual that I was very much focused on the things I wanted to learn, or the things that I wanted to like, skills that I wanted to have. And I think if anything, I guess maybe I approach it slightly differently, where the more experiences I have, the more that I learn the lessons about what I need or what I don't need. Like, I guess I just don't have the ability to know that ahead of time. And so as I've gone through different experiences, bad or good, I've come away with it with the knowledge of like, I need this thing in my life, or I really don't want this thing in my life. But I will say my happiest days are the days where I am in my PJs at the computer and I get to code for like 10 hours. And I'm just like lost in it. I'm not a human being anymore. I'm just like in that zone for so long that it just is like time flies by. And I like kind of sort of drowsily look up at a certain point. I'm like, oh, I fixed it all. It runs and it looks good and it's doing the thing I wanted to do. And oh dear God, it's been that long, but yeah, it works. And that to me, like those are the days that I love. So
Yeah. No, I definitely have those moments of like struggling through a problem you've been working on for a long time, and just hitting the your hand flies up in the air and you're like, I'm the best, and like you're
yeah,
very ego driven, and it's like,
the like
it's
sitting in the
right.
chair
Like it
dance where I'm
was,
like, yes,
yeah,
yes,
yeah.
that was
Like
me. That was
it was stupid and it didn't work and it's all bull crap, and it's like, but
me. You
I'm the
can
best.
swear on stream. It's okay, by the way.
Okay. Yeah. I didn't know how far to take it, but yeah, so
I swear like a sailor normally, so you're fine. Um,
okay.
I've actually had people in stream be like, "Are you okay? You're not swearing all the time." So don't feel free to be you, but
I,
it's the best feeling.
yeah, yeah. No, it's amazing. It sounds so egotistical to like hear yourself say those things later,
Does
but
it
in the
though?
moment there's just a
Oh,
huge rush of endorphins and like just excitement and energy, and you're just like, there's
yeah.
literally nothing right now that could happen that could make me not happy.
And
Those
Ray
are
Marsh, you
great.
say you're in real life standing up for that dance when it works after 4 hours of coding. Oh,
Yeah,
four is a good day. But yeah, it's like it's exactly that though. And I mean, later on, I kind of like caveat things. Like in the moment when I run it or I
yeah,
compile it, and I'm like, oh
oh, yeah,
yeah, you see that? That's me. I'm queen of the
yeah.
universe. This is awesome. And later, I'm like, literally built something really simple. Like chill your shit. But
Oh yeah,
it's that moment of like, because it's not about the ego in the moment. It's not that you
right,
really do think you're hot stuff. It's the like euphoria you get from solving a problem or solving a puzzle.
right.
you found the answer,
Yeah.
you fixed the thing, and it works. And that feeling is amazing.
Yeah. I just mentioned that it's about ego because typically what I will like actually what the words that come out of my mouth are like I'm the fucking best. It's like that's right. And like like I'm just so happy and excited. And then of
Yeah.
course like later it's like actually it's like really simple in hindsight. Like it's not amazing at all. It's just the intuitive thing you might have expected, but for whatever reason it took me a long time to get there. So,
No, I'm right there with you because in the moment I'm like, that's me. I did that thing.
yeah.
Everyone should see how amazing I am. And then like once
Yeah.
once the like the brain chemistry like settles down, I'm like, oh yeah, that's actually not that cool. But like I still feel a sense of accomplishment because like I know how hard I worked to do it. But like I think less that I am hot shit, and I think more like, good job. You solved the thing, you persevered, now on to the next thing. But in the moment, hell yeah, it's all about like, I literally am the best person in the universe. Like, bow down mortals. I did that thing. And
Right.
when it's like really
Yeah.
basic. So
Yeah. Yeah, or like the other side of that is when it's something that is super complex, like almost objectively, and then but you realize after figuring it out, it's like there are like three people on the face of the earth who are going to understand the problem I just identified and how I fixed it.
that's
And
so
like
hard. You can't tell anyone how amazing you are.
because then like my college roommate is one of those people for me, and so
Mhm.
like he gets all excited and celebrates with me and is like that's amazing, I can't believe you even figured out that was a problem, like. And it's like when you legitimately find a bug in a library or a piece of software that's very very widely used, it's like it's never a bug in Python, like come on. But like one time in particular I'm thinking we did find a bug in Python, and we were like, wait, no,
Oh,
this
that was so
can't be
cool.
right. Like this can't be right. We can't be the first person, the first people to run into this and to like figure out what's going on. And turns out that was the case. We filed a bug report, and I don't know. I didn't follow up. It was right before I ended up leaving that work. But anyways, but the point was like when you find yourself in that position, and it's like I have to take hours to explain to somebody why this even showed up, and
Yep.
then like to explain to explain like what's going on, and then like to explain the bug it's going to be another long time, and then to explain the fix it's going to be another long time, and then to make them you can't make them understand why it's so exciting. Like they have to get it already, or you're just not able to explain that.
Yeah, and it's like it's interesting too because like poor Loafbone gets dragged into my office because I'm like, look at this code, and I have like a gazillion scripts up, and he's kind of like, yeah, that looks great. Like you look like you did a thing, and I'm just like, no, but you gotta understand. Like, do you see this code here? Do you know what this does? And he's just like, no, but I trust you that it's amazing. And it's like, no, but I need you to understand how amazing this is. And so that's always bundles of fun. But so we'll answer this last question, but then for both of us it's getting late. But third you gave me a question, both of you. You are talking to your future family about your job. What is your proudest moment in that job?
I think I have a lot of career left before I could answer that question accurately. So far,
Like so far,
um,
what is your proudest moment?
I cannot share the answer, but I have
Damn, yeah,
something.
I'm trying to
And
wonder like yeah, it's like this is part of the problem with what we do is that a lot of times we can't talk about our proudest moments. I will say for me, it was working with a group of very non-technical people, and they were doing things very old school. So if you imagine that maybe you are working, like I'm thinking back to when I was a paralegal, for example, and everything we filled out for court was handwritten. And like we had to fill out all these documents that were handwritten, and sometimes we typed them up, and it was like all this laborious manual process. And so I was working with a group of people who were very focused on humanitarian aid and helping people and preserving human life. And they had very, very basic sort of workflows. Like, so everything was done like me as a paralegal, like everything is handwritten or everything is like very laborious. And so I was able to build them software that not only automated all of those processes, but also did some cool machine learning to help them make better decisions. And it was this great feeling of like not only getting to help people, but getting to help the people whose job it is to help other people. And to kind of step in and do it in a way that builds trust and like explainability. So everything I did was very like transparent, and everything was really well documented because that trust was really important. And so to me, that's the proudest I've been, because I also, for better or worse, because of project structure, I did it single-handedly. I was the only person who knew how to code on this project. And so from the ground up, I built this software for non-technical people to use that automated a lot of their workflow and also helped them make decisions. And so I can talk generally about that, but I can't go into specifics. Sorry, friends. Hopefully someday in the future. Oh,
Sorry.
what? What did I miss? No, I'm catching up on chat. Sorry. Oh, you created sentient AI. Oh, goodness.
Just can you hear me okay? I don't know if I can hear you.
Can you hear me? I can hear you.
I can now.
Oh, okay.
Okay, you're cutting in and out. Yeah.
Oh, no. Okay, well, my mic is shitting itself, so it's probably a good time to wrap things up anyway. At the end of stream, I really like to raid small streams. So hopefully all of you will stick with me. Let's raid a tiny stream. I almost feel bad doing this because she always gets so flustered. But let's raid our good friend Nidia Only, because she was here earlier for us. She's learning CSS. So if any of you are CSS experts, please stay with the stream. And let's give some love. And then I will see you all next time. All right? And everyone, like, F's in chat, are those good or bad? Everyone just thank Tyler. He's awesome, and hopefully he'll be here soon. Again.
The chatter chat just thanks everybody for having me on.
All right. 5, 4, 3, 2, 1. Bye, friends. Stick around for the raid.